I know them, but if you already, because I do not have the bio with me.
Hello, hello. So, the time has come. It is my pleasant duty to welcome everybody here at one of the venues of the University of Zurich for the Ethereum Zurich. My name is Joseph. I'm here with several heads. I'm part of the Institute of Cryptonarchy, the duct tape production who also organizes ETH Prague, and one of the sponsoring companies called Pawn. Honestly, this is my dream come true. I've been in Switzerland for several years, and I always had to travel elsewhere into the world to attend one of these Ethereum community conferences. And now finally, one is happening here in Zurich. So I'll be quick. I just essentially want to thank you for attending, for being here with us for the 3 days. I also want to thank the sponsors. I want to thank Sentiment, Near Swarm, Octan, Tenderly, Nethermind, and many other sponsors that enabled us to throw a conference for several hundred people with most of the tickets given out for free. So there is a conference part which already you are now witnessing, and there's also a hackathon part which will be introduced by the end of the opening speech. But without further ado, I would like to invite Claudio Tessone, the professor of the University of Zurich and the head of the blockchain center of the University of Zurich with the opening remarks. So please put your hands together for Professor Tessone.
Thank you. Thank you very much. Can you hear me? And it is also with the microphone. Great, fantastic. Welcome everybody to the first ever conference, Ethereum Zurich conference. It is for me a pleasure, and I'm really thankful for the people that has been organizing, that has been leading the operations on the organization of the conference, the Pawn people, the people that has been also doing ETH Prague, etc. And it is fantastic to welcome you here because Switzerland has been fundamental for the development of Ethereum. And this is why it was funny that communities all around the world were able to discuss and to look into entrepreneurship, business models, applications on top of this blockchain. And a conference like this never happened in Switzerland. Ethereum was, as you may know, originally thought a decade ago, and after considerations on how it could set up, how the people could bootstrap, the founding members could bootstrap resources to be able to finance the development and also the creation of a whole ecosystem. It was Switzerland, and specifically a very neighboring city to Zurich, that is Zug, that for the first time that enabled the process of the creation of the Ethereum Foundation here in Switzerland. So this translated into many things that happened in this country. This country has advanced a lot in terms of regulation, creation of the regulatory body to accept different kinds of digital assets, create from startup to foundations, the governments all around of different cantons and also the federal government were able to create a very interesting framework here. And this created a very interesting ecosystem that we are really happy to see represented in the conference now. A little bit of words because this conference is hosted at the Blockchain Center of the University of Zurich. We are the largest university in Switzerland, the largest university in terms of number of students. We have 28,000 students. But the most important thing, when I want to say that the University of Zurich is the largest one, I am much more interested in mentioning the fact that we are the one that covers the widest range of knowledge areas in this country. And actually, and this is how the Blockchain Center is conceived as well, we stand that in order to fully understand blockchains, interdisciplinarity is key. We cannot look at this, and in general, this has led to a lot of problems in platforms that were developed inside of blockchain-based solutions, layer 1, layer 2, everywhere. Economic incentives are fundamental, governance is fundamental, but also regulatory bodies are fundamental. And all these areas are part of the research that we are performing at the University of Zurich, and about which you can learn more either in our stand outside. We have a booth that I am really thankful to the members of my team that are providing information to those of you who are interested. And on the other side as well, we can also talk about this in more detail later in different presentations that we will have in this conference. The Blockchain Center of the University of Zurich is a competence center, actually, of the university, which means that we are a legal entity that has a clear mandate from the university, on the one side, to foster and coordinate excellent interdisciplinary research, as I was explaining before. The second one is to create a complete educational program for our students. But not only. We are very interested in addressing people from all around the world to teach about blockchains to people all around the world. That's why we have a summer school that we every year offer. This year is already on the 4th iteration that is called Deep Dive into Blockchain. And we also offer courses to people from industry who is interested in learning more about blockchains. This is the second role that we have, education. We are a university. The third reason, and this is why we are here today, is to act as point of contact between all the stakeholders that are important in blockchain-based systems. And communities are fundamental when we want to understand the reach of different blockchain-based systems. And this is why when we were approached to have this Ethereum Zurich conference, we were so thrilled. And the final reason, we want to consolidate these 3 points that I was describing before by mentioning that what we always want to achieve is a critical understanding of the space. We are not accommodating to the space. We want to really want the space to thrive. And the only proper way of doing that is with a neutral knowledge that the stakeholders like universities, I am really happy to see people from other universities, Swiss universities here, and not only, is something that we can achieve and we want to achieve together with the community. As I said, when we were presented with the opportunity of having the Ethereum Zurich, we were really thrilled because it is a way in which we want the community to express itself. And this is why we are so thankful to those of you that are going to be present here, who are going to be introducing your own projects, your own ideas, and to nurture this ecosystem in this new day. So thank you very much for attending this conference, and thank you very much for the program that you yourself created, because this is also your space. The last thing that I want to say is that now we are going to start with the program, and there is a very important aspect of this, that is understanding how the technicalities of the hackathon are going to be, and this is why I welcome Jacob now to the stage. Thank you very much, Jacob.
So, yes, I'm Jacob. First of all, can I see hands who's here for the hackathon more than for the conference? Come on, put them up. Okay, not bad. So, if you see these hands, these are the hands that are about to get dirty. So we have a hackathon because, obviously, We need people in this great ecosystem who will be building it brick by brick, block by block, commit by commit. And that's such a crucial part of the whole sort of progress and going forward that, of course, you need a hackathon. And so we do have one. Can I have the next slide, please? Yeah. So, great. Many of the tools, protocols, all the things we all use and love have actually originated in hackathons, but not just by putting the ideas together, but also by sort of building the connections and bumping into people, having interesting conversations. And that's why we're gonna kick off the hackathon right after this, basically with a team formation session. So that's gonna happen in the Hacker House, which is I'll show you in a minute. And that's where we basically welcome all the hackers, make sure that everyone has the skills that they're looking for in their teammates, even help them find some cool ideas, projects, problems to tackle, and basically have everything they need to start hacking. And then the magic begins. And for the rest of you who are not attending the hackathon, I would like to invite you tomorrow at 5. There's going to be an opportunity to basically peek under the hood of what's going on in that house. I'm not sure if it's safe to go there in person because, sometimes it gets a bit intense, but hey. On Saturday, we will have a project showcase, and that's not something that is always done in hackathons, especially not like halfway through the hackathon. But it's really great because it's an opportunity for everyone to see what everyone else is up to, which is, there's also like a bit of a competition going on, obviously, so that's good. But other than that, it's just informal. You don't have to be nervous about it. But I would say it's good to prepare for that a little bit as well. And for you attending the conference, again, I would like to invite you there as well. The whole schedule is in the hacker manual. I'll point you to that in a second. But then obviously the big sort of closure, what everybody is waiting for, is going to be on Sunday, the closing ceremony, which is going to be in this building again. So obviously the hackathon wouldn't be a hackathon without some prizes. And again, while all you here attending the conference are here, I'd like to speak about the first part in particular. That's called quadratic voting. So you all got cards like this, and those are going to be very important. This is how you vote for the projects that you like, and there's some prizes involved, as you see on the screen. So study the instructions here on the back side of the card, but also on Sunday, I believe, we're going to have a little sort of session here, a little presentation about how the quadratic voting works. So that's going to be the main part of the competition in the hackathon. But then we also have $2,000 that will come from our judges, and those will be divided to their favorite projects. Also, we have 3 sponsor bounties. Those are combined close to $3,000. So again, if you see people come back here on Sunday smelling and looking like zombies, you know why. They've been working hard. So for all the hackers, we will make our way down to the Hacker House, which is basically if you just walk out of the building, walk to your left, and it's like, 200 meters, something like that, not far at all. I will be somewhere along the way. Tree here, who's organizing the hackathon, will be somewhere along the way, and we'll find you there. All of this information is also in the hacker manual, and I would encourage you to read it. This is where you can find it, and that's basically it from me. Yeah, this is the time you're allowed to get your phones out. So that's it for me, and I'll see you around during the weekend. Thank you.
So just in 4 minutes, we are going to start with the programming. So next up will be a panel about the Swiss crypto ecosystem. Since we have a few minutes, I just want you to know that there is another stage, the execution stage, where you can also see some of the talks. For the schedule, please go to ethereumzuri.ch, where you can also check out profiles of all of the speakers. If you have the time between for networking, definitely encourage you to go to the cafeteria to check out the sponsors and talk to the people at the booths. And yeah, well, I hope you all enjoy Ethereum Zurich. Again, thanks for being here, and see you again in 3 minutes. So, hello again. So, we'll kick things off with the panel. The panel will be about the blockchain, Swiss blockchain ecosystem, because as all of you know, Switzerland has been integral to the entire development of the crypto ecosystem. So, please welcome to stage again Professor Claudio Tessone and two Swiss entrepreneurs, Mark Degen and Nikolai Reinbold, for an interesting discussion about how things are in Switzerland.
I am applauding them, people. Thank you. It's a very weird idea. Thank you very much, and thank you for staying here. And it is great to have here Mark and Nikolai, who are very important members of the community here because they are representing two very important initiatives, activities that are taking place in this country. One of them is, I start from you, Nikolai. You are a community leader from CV Labs.
Global head.
Global head, sorry, because you were promoted last year, right?
Yes, after leading the CV Labs.
Exactly.
Exactly, yes.
Thank you very much. And then Mark Degen, who is the CEO from Trust Square. So welcome everybody. Can you please introduce a little bit yourself and the activities that you are performing in Trust Square? Mark, I start with you.
Yeah, so basically Trust Square is located in 3 locations here in Zurich, more or less around 5,000 square meters we have, where we have 3 different activities. So basically we provide a co-working space for tech innovators. We run a series of events. We also had 2 side events yesterday and the day before to this event here. And also we provide a series of different services to help entrepreneurs operate their core operating system. And Trust Square was established end of 2017. The idea came together that we need somewhere a space where all those crypto innovators somehow can meet and interact. And why was this so important? Because at the end of the day, also from the own entrepreneurial journeys, we learned that there's so many accidents that happen somehow that evolve into big things. Everybody of us has somewhere in their past, in their history, this small little thing that happened. A person you met and now you're married and you have kids. A person you met and now you just created a company and you had a great idea. Somebody that told you this is bullshit and you avoided doing it and went for something else. It's also completely changed your life. And this is what I call a little bit this entrepreneurial butterfly effect. And this has to happen when people come together. And this is the purpose, the core purpose of Trust Square is at the end of the day, we want to bring all those like-minded people together in an entrepreneurial spirit that want to expose themselves to new edge technologies, like blockchain being one of them, and go through all those little accidents that have to happen to create something big that not only changes their life, also eventually, over time, also impacts all our lives. And this is more or less what we stand for.
Fantastic, Mark. Thank you very much. We also have accompanied your journey, starting from Bank of Strasse and now to this new place, also now growing into the lake as well. Nikolai, CV Labs then, and CVVC.
And CVVC, right. So we have 2 brands. I'll start with the first one, which is CVVC, stands for Crypto Valley Venture Capital. So we are a VC investing in blockchain technology or Web3 technology. Established 2016, but starting to invest in 2018. We invested in roughly 60 projects globally. 41 went through our acceleration program, and the rest was direct investments. But on the other hand, we have something similar to Trust Square, because we believe that just investment is not enough. We need to support the startups a bit more, and that's why we founded CV Labs, which is, so to say, the ecosystem builder of CVVC. Under this brand, we have multiple activities and services. So one would be co-working spaces. We have one in Zug with roughly 150 tenants and blockchain tenants. So everything what I'm talking about is blockchain. or Web3. It's here in Zug. Then we have one in Vaduz, Liechtenstein, in Paris, in Berlin, in Lisbon, Lisbon, and in Cape Town. As well, we do a lot of events, community events. At these hubs, we have a flagship event called CV Summit, roughly 1,000, 1,500 attendees per summit. The next one will be in October, where we have a lot of corporate partners, because we try to build a bridge between corporates and startups. So, last year's event, we had like Visa, Citibank, Google, part of the event. We do as well regional reports, where we kind of showcase what's happening in the different regions that we're in the Web3 space. And last but not least, on the brand of CV Labs, we have our acceleration program, where Claudio is as well doing workshops. Yesterday, no. Wednesday, you did a workshop, our program, because we are at our 5th batch at the moment. It's a hybrid program going 3 months, when we have roughly 150 mentors and experts from, all key players in the industry, from the L1s, Near, Polygon, Cardano, you have the exchanges, market makers, auditing companies who support our startups throughout their journey. And then in a nutshell, we are a venture capital with a plus. CV Labs is the plus, and under this brand, next to investment, we give startups a space to work, a voice throughout our events and activities, and the whole network and community building part.
Mm-hmm. Thank you very much. I think that in a way also your activities are complementary, because you have been building together, and we have done a lot of collaborations with you. We have the lecture series together with Trust Square. We always welcome as well the students from our programs as well to CV Labs, so it is a fantastic community that we are building here. And perhaps the first question that I have with respect to the Swiss ecosystem, which is an important thing. We were mentioning today, there are a lot of startups, there are a lot of associations, a lot of initiatives. Now the people from the NFT Association is here, but there have been several over the years spanning and flourishing. So if you are talking to an international crowd, so why should Switzerland be the location for a Web3 venture, Mark?
Well, I think there are multiple reasons. I mean, one is, from my perspective, the most obvious is the easy clarity you have basically in the foundations of your company. So we have a very accessible ecosystem also from a governmental legal compliance part, where you have a predictable outcome. I mean, whether you like it or not, it doesn't matter. At the end of the day, at least what the outcome is, it is what it is, and it stays the way it is. And this is something where you have a foundation. On this foundation you can build. And also there is the whole regulatory space is also a little bit in a wait and see, let's say, principle. So basically they also let stuff happen and basically just make sure in a certain aftermath that it's somehow on a good, let's say, compliance. And I think that's a very, very important foundation where you can build something on, and then you have, of course, all the other attractive reasons why being here, from having access to talent in all different things, in being used, working in international settings. That basically it's totally clear that you have a mashup of a high diversity workforce that's here. Switzerland is used to work with abroad collaborators, so you have a very easy way to operate, because yes, of course, we have an extremely high cost level, but I mean, there is basically no company that has 100% of their staff here, and also the whole ecosystem supports this. And I think this combination made it quite unique a couple of years ago, that you could start something and it still exists, and it could be built on here, and actually then flourishes into what it is today.
Nikolai, you then. I think that perhaps you share the view of Mark, but which are the key players that you think that are needed in order to have such a strong ecosystem?
I mean, you always, I mean, I totally agree, Mark, what you said, right? The foundation, it's the government that you talk to, which is important. You can talk to the government and they set rules and it's clear, right? The outcome is clear at the end. And this is one important player, right? So the government needs to be active or kind of, wants to learn and implement rules, right? Then you need to have, obviously, talents, right? So you need to work with universities, universities active in ecosystems, especially when you talk about tech, doing research and so on. You need to have founders, so you need to have startups who obviously start building that. You need investors, because you always need capital to fuel the whole ecosystem. You need corporates who are looking for innovation, to work together with startups working on pilots and that. And Switzerland, if you look in Switzerland, you have that, right? As well, when you look in Zug, because we are based in Zug, which I can talk a bit more, there you have, for example, Siemens right around the corner, and this as well active in our acceleration program, supporting the startups, right? So I think these are kind of the key players that you need to have involved in a strong ecosystem where you can build a strong ecosystem. Mm-hmm.
Thank you very much, Nikolai. You know that a few years ago, you mentioned, Mark, 2017, when you were founded, one of the, I always remember that you were in the Bahnhofstrasse, just in front of the SNB, and in that original night in which there was the launch, there was this projection of the Bitcoin logo on the SNB Bank. Do you remember this thing? But then, what I'm saying is, we have been living for quite some years, and you have been present, we have all been present and seen how the ecosystem evolved over time. Can you please try to build up, for the people that do not know it, a little bit of the history of how the ecosystem grew over the years, and how did you get involved? Actually, it's also a very interesting thing that I always want to learn.
How I got into the ecosystem, that was
an accident.
That's exactly one of those butterfly effects, and it's also, what you also said, this accessibility. You could phrase it as accessibility, and so. And I came across the job ad of the Ethereum Foundation when they were looking for a managing director. There was some kind of a sentence up there that catch my eye. I was like, what the heck is this? And went somehow down the rabbit hole. Of course, I only understood about max 1/3 of the blog posts of Vitalik back then. Ethereum wasn't even launched yet. But I was somehow, I was coming from e-commerce, transactional telco payment background. So for me, this transactional issue was totally clear, and I totally bought in. And what I did then is, I cannot code, so what I did, I just wrote to some professors and asked whether I can do a diploma thesis with an idea. And this is also how I then, over some accidents, met, Thomas is here, was working at UCH. And this collaboration actually then led to the establishment of a company. Modum, back then, we established, made an ICO in 2017, had a great success all over the time, and with the whole timeline. Of course, there were a lot of button diffs in between, but at the end of the day, that was the accident that caught me into this whole thing, and exactly this accessibility also, that it was possible back then that yes, you could basically call up the tax authorities and ask them, how do you do an ICO? And as long as you didn't talk about tokens and just said, well, just think in Excel sheets, and if it's doing in Excel sheets, then that's basically it. And this is how we basically constructed this whole concept, and it worked. And I think this quadruple play about you have to involve governmental bodies, academics, corporates, and startups, because our first big client was the Swiss Post, where we actually launched I guess the world's first enterprise product in the market, launched, that was using a blockchain, actually for silly reasons, if you look back today, but it still did. And you had, everybody dared to do this, and this was 2017, 18. That was very, very early. And I think this is where this all then evolved. I mean, back then it started, and so we were focusing also from a Trustware side only on startups. And then we saw, okay, well, startups in the co-working might be not the perfect cohort of customers because they're dying by design, either because they grow out. So, for example, Signum was established, had their first office at Trustware back in 2018. Now they have a couple hundred people. We had B3I in us. They don't exist anymore. I think this all happens, and this is also why we involved our service portfolio around that, because we saw, well, on the one side, just banking on co-working startups. We saw what happened with WeWork, so okay, we might also think about let's let corporates in, because in the beginning we declined all corporate requests because we thought we have to be pure, and then we added all those events because we got just requests to do events. It wasn't a plan; it just happened, and then well, okay, we could actually also charge for that. And the same was also then for the services. So where we saw, okay, all the startups have issues with insurance and VAT, and then how to get a bank account, how to get the accounting right, especially if you mix then fiat with crypto. And we also had the problem ourselves. So we solved it for us. The more I talked about this, the more clients we got. And this, I think this is the evolution and the accessibility, which is especially simple in Switzerland because it's still rather small. Yeah. So you can access everybody somehow, at least via one or two connections.
Yeah, absolutely. Nikolai, thank you very much. Nikolai, how did you get into?
How did I get into? So I was a student, my bachelor. I was doing a lot of startups since I'm 17. So I had like a co-founder, which I'm doing all these projects. Then one day he told me about Bitcoin. He's like, yeah, there's Bitcoin Swiss. I think I'm going to join them as well. So I was still in my studies. So he became the 5th employee at Bitcoin Swiss. So for those who don't know, Bitcoin Swiss is a broker who was one of these first company in Switzerland, founded in 2013. Have now roughly 250, I believe, employees. Here in Switzerland. So he became like the 5th employee. I got more interested, and then I did actually my bachelor thesis with one of the 2 big banks, or now there's just one, so I did it with the one that still exists. I did a blockchain framework for them, 2017, for their foundation they have. And like this, I kind of got into the space. I used to do, in my last year of my bachelor's, I did an internship at a firm called Inacta. It's based in Zug. And one of the 2 founders founded then CVVC and CV Labs. And I was then the first employee building up the acceleration program from scratch. Yep. That's how I get in there.
Thank you very much. And how do you think, because you were mentioning, this space is always characterized by turbulent periods. We have been there in 2016, we have been there in 2019, we have been there as well last year and perhaps as well this one. But specifically with respect to the last one, the one that we are still perhaps experiencing, how do you think that the current financial turmoil has influenced the Swiss ecosystem? And it is, you're staring at me, so I start with you.
Well, I had exactly this discussion basically yesterday night over dinner, where we were a little bit trying to this discussion about was it now good, was it bad, blah blah blah. I mean, at the end of the day, the outcome, the true outcome on the economy, I think we know maybe in 5 years, because if you see all these cross effects that are happening, now it's talking about those 2 big banks. I mean, UBS now doing insane revenue or EBITDA reporting, which has a crazy tax impact, which again offsets other effects, or due to the just some legal details that there is an ownership change in the real estate portfolio of one of the biggest real estate owners, Credit Suisse. There is a vast amount of taxes that have to be paid. So is this now offset with the social impact? I mean, I don't know. Probably somebody at the University of Zurich will soon figure this out. But I think there are so many cross effects. The only thing you can do, you can just take the fact and move on. And this is basically also the same, and it's the same behavior that I'm not that shocked by that, because I mean, I saw now 7-8 years crypto. Well, you just take it and move on. Yeah. That's the only thing you can do. And everything else just makes you nut. And if you go and try to figure out all those variants, what might happen, I mean, you can also take another theory. I mean, how can it be that somebody, that we are all talking about a huge market with huge volumes, where the biggest liquidity provider on earth, nobody knows who owns it, whether they omitted some sanctions or not, where their domicile is and all this. I mean, how can such a market even be seen as a market as long as this thing exists? So there are so many variables you can look at, where I usually get to the point, well, relax, Max, focus on the fact, and move on. Take it where it is.
Yeah. Nikolai, and specifically with respect to all the crises that were triggered in the blockchain ecosystem itself last year, what do you think do they represent a threat or an opportunity for the Swiss ecosystem?
So I think it's an opportunity, right? It's again an opportunity, and you know, what happens with FTX and so on at the end, you know, what shows is there's bad actors. It's not a bad technology. You know, back in the days, blockchain is bad, blah, blah, crypto is bad. No, that's not true. It's the guys behind it, right? And you have this in every industry. But there's a lot of trust again in Switzerland. Obviously, the bank situation doesn't help that much, but in the space there's a lot, right? So you know, foundation-wise, you know, as we said before at the beginning, having clear structure, we know the outcome. You know, we are regulated, we have rules. We see a lot of startups coming internationally asking again more to set up something here in Switzerland, you know, set up a foundation. I have this call almost weekly to set up a foundation in Switzerland from the States. A lot of people want to move out in the States, from the States to Switzerland, move the company, or to Europe, I would say to Europe, not just Switzerland, right? And obviously, you know, crypto winter was here. Maybe we are now in autumn, spring. We're now in spring. But you know, important is this is not our first crypto winter, right? Yeah. And what's important to know, especially, you know, for you guys who hack, it's a time to build. The best projects come out of this crypto winter, right? And I think that's something we need to, you know, to have in mind and you know, go in the right direction. But yes, I would say I think it's it could be a positive outcome for the Swiss ecosystem. Yeah. Stuff that happens.
Thank you very much. Once again, we are here in Ethereum Zurich. So which is the role that you think Ethereum has had in all this history, but also is currently, which role is it playing now?
Well, I think the vision and also the execution behind Ethereum was the main game changer. And for me, also coming a little bit out of a let's say, a little bit idealistic touched world of let's remove fiat from the ecosystem, more to this combined, I can transform or transact value and information and ownership representation at the same time within one transaction. And I think this is the key thing with all the flavors that evolved out of it. And you also see this basically at Ethereum Mafia. I mean, as the PayPal Mafia exists, also the other one exists. There were so many incredible other things let's say, grew out of this initial thing. And at the end of the day, I mean, Ethereum is still the king. What it's all about, adoption and usage everywhere. So I think that was the event in the last 10 years.
Yeah. And I think important for the history of our ecosystem here, I think Crypto Valley would not be Crypto Valley if Ethereum didn't set 2014, 15, the foundation here in Switzerland, right? I mean, that's why we have Crypto Valley, is because Ethereum built up the foundation here in Switzerland.
Yeah, actually it completely changed the landscape, because also they said completely transitional point. Before that it was much more, let's say, disorganized communities or governless communities, and now it became to everything that was created afterwards comes also with a legal entity in a way that is trying to steward the things. Absolutely. Let us go to the labor market here, the situation here in Switzerland for the last few minutes. How do you see that it is the labor market in Switzerland? How easy is it for startups, companies, to find the talents that they need?
So in Switzerland, we have around 1,200 blockchain companies active, right? Roughly 6,000, or there was last year's number, right? So 6,500 employees in these companies, which is a growing market if you compare it to, like, you know, two years ago, where I think employees number were at like 1,000, 1,500. So it grew quite a lot. However, even if we said that, you know, build a company here, set up the company here, Switzerland is super expensive. You will find a lot of good talent, which is it's super expensive for the startups. That's why you have a lot of companies looking in Berlin or in Lisbon to find talents there to support the company. But you see a lot managers, marketing, CTOs based here in Switzerland. So like the high levels are still based here in Switzerland, but the rest, because we're still decentralized, right? At the end, it's still about decentralization. People have their laptop and they can work from everywhere, which, you know, it's just the new way that, you know, people are working, in my opinion. But however, the whole ecosystem supports the labor market. So it grows and grows and grows.
Fantastic. Thank you. And what do you think that the government, because you started with this clear regulation, yes, and this is the last one, how can the federal government or the cantonal governments like Zug or Zurich can contribute to improve the situation?
Don't interfere. Okay. You know, I think... No, I mean, to be honest, I'm not a big believer in governmental programs, especially not in a working environment, and I would consider Switzerland as a definitely working environment. And if anything starts happening in starting interfering in some punctual support here and there, I don't think that truly helps. This more helps keeping stuff alive that shouldn't be alive. And I think the best area where you find whether your idea, whatever you build, whatever you want to do has value is if you have a market that pays you for the pain or the problem you solve, and that's it. And you can do this in a small scale, you can do it in a large scale, and there are plenty of opportunities where I don't see any governmental interaction that can help at any point in time.
Fantastic, Mark. Thank you very much, and this is very much in line with the notion of community that we are trying to bring here. Thank you for this nice panel, people. Thank you very much for that.
Take the mics. You see, Bundesliga microphone event is zero.
We are back. So next up, we are going to have a talk about the importance of communities in the building process. So obviously something very important to the Ethereum ethos. The speaker is Maria Magenis, and I actually love how she was introduced at the Humans of Crypto podcast. So please welcome on stage the Italian powerhouse who has been involved with essentially all of the major DeFi projects that you know.
Is this the thing? Yeah. Okay. Hi, everyone. I'm Maria, and I'm. Where are the slides? Okay. Okay. And I'm here today. I'm Italian, and I'm here today to talk to you about the importance of community building. Why? I want to introduce a bit myself and tell you why I'm able to talk to you about this topic. So as mentioned, I am involved in the space since 2018, so almost 5 years now. And I was involved in the major, let's say, DeFi projects, so Aave, MakerDAO, Balancer. Now my main jobs are Oasis.app, and Spaghettis, the Italian community which I founded with Matteo. And I am not a technical person, I am a marketing person, so that's why I'm here to talk about this topic. Recently, I listened to a podcast by Amanda Cassatt, who is the former CMO of Consensus and the founder of Serotonin. This sentence was really powerful to me because it's really true. So while products and projects represent the bones, marketing represents the muscles. What does it mean? It means that marketing is just as important as the project itself. And it has to be very clear in the founder's mind, because if you just have the bone, you don't move. And if you just have the muscle, you also don't move. So you need both. But what is the community for Web3? Web3 marketing is not the same as Web2 marketing or in general other spaces marketing. It has the same, let's say, areas, so events, communication and PR, social media, contents, campaigns, whatever. But there is a basic difference that I have noticed during my years in the space, which is community and community building represents the roots to build everything else. And that's why my presentation is called like this. But there are different types of communities in the space, and the ideal world is to have all of these types of communities all together forming your community. But let's talk about the different communities. So we have we see the builders, the community of builders, which are mostly interested in developing on top of your project, of your protocol, of your technology, and they come together as technical people, as developer. Then there are the enthusiasts who are really into like what your project or protocol can deliver and what is the final goal, what's the benefit for the humanity and the society. Then there are the users, so who uses your protocol or project or your service, let's say, because there are also dApps that are standalone, so users are your community in that case. Then there are the token holders. Token holders is quite, to me, a bit like, so they can be like healthy, that they can represent an healthy community, or just shielders. I prefer the healthy token holders. And basically, they are these people that believe that the token value is strictly connected with the project success. And then, finally, but also very, very important, the team. So I saw, and I have been involved in a lot of different projects, as mentioned, and some of them, in some of them, the team was not, like the culture and the team behind was not very healthy. And it's very, like, you can see the correlation between an healthy team and the success of a product or project. Meaning that the team is the very, very core and primary community that you are building on top of. So as I said, the ideal is to put every one of these people together and build your community. Finally, my presentation is very short and easy because I just have 10 minutes. I want to talk about some tips, some like best practices, let's say, on how to take care of your community. And then if you want to know more, you can reach me and I will also be happy to tell you more. But basically what you need. As I said, the very first thing is the team. So you can have either one person or more than one in your team taking care of marketing and community, but it's very important to try to have this person from the very beginning. So a lot of projects try to hire, to get on board a person, a marketing person, after 1.5 years they already have the idea and they already started to work. This is wrong. From my experience. So you need to have someone marketing/community from the very beginning, because he needs to be involved, or she, better she, needs to be involved from the very beginning of the project and to be like very into the core of what you're building and what you want to achieve, to be able to pass this passion to the rest of the world. The second point is be open and patient. For example, this is a good example, at events, big events, when you have the booth and you are sponsoring with a stand, with a booth, you receive a lot of stupid, like not stupid, but a lot of questions which for you can be like, but you need to explain, you need to be very open, patient and explain, because everyone is welcome to learn and we are a very small space right now, and in order to scale we need to be very not snob, so be inclusive, otherwise we are not going anywhere. The third thing is developing relations, so go to event. If you can't go to event, just like message with people involved with other projects, try to do activities together, cross-marketing campaigns, cross-communities, etc. And finally, be creative. So building a community is very difficult, especially when you don't have a token to like build on top of the token. So grabbing people together is not easy. Try to be as creative as possible. For example, making like trying to involve people, users or whoever in building in the actual build of your product, so asking feedbacks, making some incentives campaign with POAP or whatever, and this kind of activities. And these are the 4 things that are most important for me, and that's it. I think my time is over. Okay, thank you.
Well, thank you, Maria. So next up, we are a bit behind schedule, so we are going to continue with the next talk. Very current topic, balancing the goals of DeFi with traditional finance. So please welcome to stage Tim Weingärtner, the professor at the Luzern University.
So yeah, thanks for the kind introduction, and welcome also from my side. I'm with the Luzern University of Applied Science. We're based in the Crypto Valley in Rotkreuz. You see our nice campus in here, so I'll invite you to come to central Switzerland. And I want to talk a little bit about DeFi, decentralized finance, and traditional finance. And these are the wrong slides, because these slides are for Sunday, for the workshop. So perhaps somebody can change this. And while we get the new slides, just a short question for me. Who of you have bought some DeFi products tokens? Wow, that's cool. Who is new to the blockchain industry? No newbies? Or nobody wants to get exposed in this crowd? And who developed his or her own smart contract? Wow. Okay. Then we can speed up the beginning when I get the slides. Yeah, while we were waiting, just a couple of words to myself. As I mentioned, I'm working for Luzern University of Applied Science. Beside this, I'm also president of DEC Institute Association. We're offering blockchain certificates, so if you want to have a look into this, we just 2 days ago launched our collaboration with edX and also offering blockchain MUX. And I'm also involved in DIDAS, which is focusing on self-sovereign identity, and tomorrow we also have a panel discussion here. So, always the bad thing if you have 2 presentations and on the same topic. So if you're interested in getting your hands a little bit dirty on this topic and also discuss with us, then I also invite you on Sunday at 12 for the workshop. There we have a more interactive topic, but yeah, so let's get started. I think if want to go through the first slides, and what I want to present in this short presentation here is to think about risk management in DeFi. And I know risk management in DeFi is a little bit different than in traditional finance, but what I also experience is that a lot of people, when they come to DeFi, think, well, now everything is completely different, and we do things other than the old banks, the traditional finance. But I also think that we can learn a lot from how risk management is done in traditional finance. And also think about how can we use the features of blockchain, which are, I think, the most important is immutability, so that you have your ledger, and once information are there, they cannot be changed. Another feature is the distribution. So you have a distributed, a decentralized database stored on different sites. You always have to look about, even if something is distributed, could be centralized. So how is the influence of certain parties on this whole ecosystem? Another feature are smart contracts, so automation. Transparency, especially when you look at permissionless blockchains like Ethereum. Then it's always the question about, here we go. Now I can go to this slide. We already had immutability, distribution, and programmability of smart contract. So the topic of transparency, as mentioned in permissionless environments, and pseudo-anonymity. Most people think about, well, blockchain, I'm anonymous on a blockchain. You're not. You're just behind an address, and there are a lot of companies that track those addresses. So yeah, don't think that you, while you're behind this address and nobody knows who you are, that you're really anonymous. You're pseudonymous, like having an IBAN number. And finally, a consensus protocol, different consensus protocols, but there has to be a consensus in order to get information on the blockchain. And with those features, we can span up a lot of possible use cases. And well, I'm really curious about the teams, what they come up, in which area, in which use case area they come up. And DeFi is just one of those aspects. So when we go to a definition of decentralized finance, then yeah, it's decentralized. It's based on a blockchain or distributed ledger technology, normally permissionless. It's run with smart contracts, so autonomous. Nobody can interfere. We'll see if it's really nobody. Then it's self-managed, so you as a user interact with the system. It's not something that somebody on behalf of you is acting, so you can decide in which product you want to invest and then directly go into it. You have no restrictions on trading hours, so it's 24/7. This is an advantage, but also can be a risk. We already had transparency, low fees compared to traditional finance products, and as I mentioned, pseudonymity. I think when there are a lot of protocols out there that claim that they are decentralized finance, but are at least centralized finance, and just a short graph of a paper. You really have to go through, and is there really nobody that can interfere? And when I think of interfere, it's also, is there, for example, in the smart contract, a functionality that you can stop trading, and somebody can use this functionality, then it's not really decentralized. Are there any governance structures that can interfere with this product? So all those checks you really have to do. And since a lot of you already know a little bit about smart contracts, I can go fast over this slide. Just as a short reminder, smart contract, the term was defined just before we already had blockchain, so by Nick Szabo in 1994, as a computerized transaction protocol, and he compared a smart contract with a vending machine. So when you go to SBB station and just get some drink out of the vending machine, you also have a this automated contract that run by the machine. And in our case, the smart contract is run by the blockchain nodes, stored on the blockchain, immutable, cannot be changed, and therefore tamper-proofed. It runs on events, so once it is called, then it executes itself, stores the updated data on the database, on the blockchain, and then waits for the next event. We're still in the stage that smart contracts are not legal contracts. So just as a short reminder, normally you have to have a normal contract beside if you really want to use this as a legal agreement. There are a couple of initiatives in this direction, but still in most countries it's not a real contract, and it's also not smart. But it can take custody over goods, and that's especially in the DeFi area, where we can implement a lot of different products. You can go to DeFi Llama and scan through the categories. I think stablecoins are most known. Then decentralized exchanges or DEX, automated market makers. A lot of those decentralized finance products, and the borders between those categories are not really clear, because you have the smart contracts, and with the smart contract you can develop whatever you like. So you can have slight variations between those, and some of the products perhaps make not much sense. Some of the products are only for speculation. Some of the products are really useful. When we look at regulation, we're still in a Wild West scenario, even that we have some legislation on it, but there are a lot of uncertainties, and people just do what they do, and they come up with new products. Also, you have to think about which country are you in. At the moment, this is highly watched by the supervisors because the amount of transaction volume is rising. There is just a new report from the Financial Stability Board on decentralized finance. I can send it to you if you like. You can also get it on the internet. And so at the moment, they think as D5 not as a systemic risk, but they have it on the watch list. And as I mentioned, regulation in the financial space, also that we have anti-money laundering and all this stuff, or KYC, is still a country-specific thing. And in DeFi, we are just out in the internet, and everybody on the whole world can interact with those contracts. So there we are, on the one hand side, we are global, we are pseudonymous, and when you think about KYC, there is some problems. As I mentioned, the legal understanding of a smart contract, and what we see is that a lot of products, due to this lack of regulation, they think about self-regulation, because normally if you want to invest in such kind of product and you build up a company around it, then you don't want to be in the Wild West, and tomorrow the regulator says, well, it's illegal, you don't want to do this. So a lot of people thinking in the industry think about how can we self-regulate it, and how can we also show that we, or people or users can trust in us. I mentioned I want to look also on the traditional finance, and I don't know if you're aware, but on the traditional finance, also especially after those crises we had recently and years before, the BITS or the Basel Committee came up with a categorization of financial risks. And Basel II was mainly 3 categories, credit risk, market risk, and operational risks. Now, after the financial crisis 2008-9, they came up with Basel III and added additional risks like liquidity risk or counterparty risk. And not only the risk categories and that the banks have to hold money for potential risks, like Eigenkapital. At the moment, we're in Switzerland just in this discussion about Credit Suisse and should we rise this from 13 to 20%. But beside those, this pillar 1, we also have supervision, and we also have this kind of market discipline. And so the question is, can we learn from what happened at the traditional finance? And I want to just come up with some of the challenges which are different in DeFi space compared to the traditional finance. So first of all, as in the name, it's decentralized, so we don't have a centralized control. Another important difference when you look at the products in traditional finance, you have a lot of products that have some kind of maturity date, so an execution date somewhere in the future. When you look at decentralized finance, and I just turn out staking, but the other products usually don't have a maturity date, so you can execute it whenever you want. And that's the reason why, for example, a bank run is much faster than in the traditional finance, where you have some kind of bounding of a product to a date in the future, execution date in the future. We don't have any supervision from the regulator. Perhaps companies supervise their own products and have some kind of possibility to stop execution of the product, but there is no official supervision. And since we operate 24/7, well, this supervision has to be somehow automated. Otherwise, there has to be somebody with a kill switch and waiting for something happening. We have code transparency. Yeah, we can look into the code. And that's, I think, also on one hand side a problem, because when you ask the people who deal with decentralized finance products and say, well, did you really analyze the smart contract and what happens there and what could happen? Normally people say no. Well, I read some description what this smart contract will do, and perhaps it's based on a standard ERC20 token or whatever. But I just want to invite you to have a closer look. So, for example, if you look at Tether stablecoin, which is an ERC20 stablecoin, there is a stop functionality or pause functionality. So somebody can stop trading Tether on the Ethereum network. And a lot of those smart contracts has some kind of built suspension mechanisms, and it's always the question who is able to execute those suspensions, and is it a DAO behind it, or is it one person, or is it a group of persons, and what is their financial motivation on this? Since the smart contracts are executed autonomous, there is no safety net if you don't have really an implementation in this. And well, challenges from a risk perspective also is the usability, because I think the whole blockchain space lacks on a really good usability. And I don't mean usability for technical people. I think we all know how to deal with a wallet. But when you go out and want to go into public and ask somebody on the train station, so, well, how do I handle or how do I buy a DeFi product and how do I sell it? I think there are the limitations. So the user group is a little bit small for this and mostly experts. In a research project, we're just looking into this and also combining traditional and finance and decentralized finance, and we divided the risks on the systematic risks, which I, as a DeFi developer, cannot influence, so the whole market risk, but also some technological risks like protocol risk. So if something happens to the Ethereum blockchain, I, as a provider of a smart contract, of a DeFi product, I cannot do anything against this. Or if I rely on oracles and those oracles have some errors, then I also depend on this. And the other side is the unsystematic risks, where we say with these risks I could handle, or I should handle. I should look into governance of the product. I should look into are there some requirements, for example, from FINMA, that I have to provide a prospectus for my product because it's as a security token. I should do an audit of my smart contract from some companies. I should look about reputational risk. What happens if there is in social media suddenly a sell announcement or some kind of bad reputation and everybody is going to sell my product? Potential solutions, I think we're at the beginning of this whole, and I'm really looking forward also perhaps for results from the hackathon, but also from the industry in regards of risk management. I think we can learn from traditional risk management. It's not that we do have to do the same thing, but we can learn because this industry is a couple of years old. They had their mistakes in risk management, but also their gains. And I think a lot is about automation of the protocols, about reporting, about transparency, about bringing the governance into a decentralized area, not on a centralized that a couple of wallets can manipulate or can change the structure. As I mentioned, the topic of maturity date, especially when you think of a bank run, and also how can we incentivize liquidity providers? Because when you look at the DeFi protocols, you always need some liquidity. Yeah, that's the whole aspect around it, because you don't have a central bank that provides liquidity, so you have to have liquidity providers. And how can you incentivize them to stay in a protocol if something goes wrong and not pull out their money? And what we will see is the topic of KYC, know your customer, and this whole kind of identity. Where is the origin of the money, anti-money laundering topics? I think these, there has to be developed something in regards of this. So, coming to an end, I have 6 takeaways for you. Still, we're on the Wild West, but DeFi is on the watch list. I think self-regulation, from my point of view, makes sense, but we really have to go in this direction and check how can we, or how can the industry self-regulate. Then I think we have to find a balance between traditional finance and DeFi. It's not all traditional finance, it's not all decentralized finance, but I think the truth is somewhere in between. And when you look at papers in the decentralized finance area, a lot of them are focusing on the technology risks. I think there are a lot of other risks in this space, not only errors in smart contracts. But those errors are one of the biggest risks, and the other, I think, is the whole topic of reputation. So what we've seen in a lot of those protocols, that we have this kind of bank run, that there is some bad publicity and people pull out their money and then the whole system collapses. And yeah, since it's a new industry, I think it's important to get innovation in this space. I'm also looking forward to all of your solutions, and not only look at short gains or speculation, but also on a long perspective, and with this also risk management. With this, thanks for attending, and sorry for the slides. And looking forward for the break for some interesting discussions. Thanks.
All right. Thank you very much, Team Weingärtner. Are you guys ready for our next speaker? The next speaker is Henri Liautaud from Cairo One. I think the audio is a bit weird, isn't it? Well, the next speaker, I'll make it very short. The next speaker is Henri Liautaud from Cairo One, the first provable programmable general purpose programming language. And Henri will present you how Cairo One will make Ethereum and Starknet, how it allow it to scale. Put your hands together for Henri Liautaud.
Boop, beep, boop. Nice. Can you hear me? I guess not. Ah, now it seems like you can hear me. Can you hear me? Ah, this is better. Hello, everyone. My name is Henry. I'll present for you today. And I'm going to talk about how Starks and Cairo will allow Ethereum to scale in a mind-blowing way. I'm going to try to make my presentation in various steps. For those of you who are not familiar, I'm going to start by explaining really quickly what ZK rollups are and how they work. I'm going to explain to you a few basic concepts, and then we're going to build on top of that to see where we go. Can we first do a quick show of hands? Who here considers themselves a dev? Very nice. Who here has already written a Solidity smart contract? Who here has heard about Cairo? Very nice. Who here has written Cairo? Not so bad. So can you raise your hand again? All right, so all these people, you see them raising their hand? If you have questions about Cairo, don't take my words for it, ask them. No, but really, you'll have the best feedback. All right, so my name is Henri. I'm based in Paris. I'm the lead developer advocate for Starknet. So my job is to explain to people what Starknet is and how they can build cool stuff on top of it. So if you're wondering how you can build stuff on Starknet or how you can extend your L1 application and do more stuff on layer 2, you should reach out. I'm happy to answer either on Twitter, Telegram, or here. Happy to talk whenever, so don't hesitate. All right, so I'm going to start with first what it is we're building. And let's talk first about the blockchain paradox. Don't you think it's kind of weird that the technologies we're using in the blockchain space are all relatively new, right? 15, 10 years old for Ethereum, and yet they don't scale, right? There has been massive payment systems emerging in the past 10 years. You can name Alipay, Visa, Venmo. There's a bunch of them who are managing to handle thousands of transactions. How come Bitcoin and Ethereum, who are newer technologies, why can't they do the same thing, right? And when you really look at it, it boils down to the trust model that blockchain use compared to traditional institutions. In the traditional world, you have one entity, say your bank or your payment processor, who is in charge of keeping tabs of who owns what. Everything goes through their computer, everything goes through their data center. Now, this has a bunch of disadvantages. I'm not going to tell you why blockchain is cool, but it also has pretty cool advantages, right? There's only one place where all the transactions go through. And if at some point you need more capacity, you just throw more data centers at it, right? Pretty easy to scale. We know how to do that with the cloud now. Compare this with the blockchain. In the blockchain world, we don't trust, we verify. This means that we don't trust somebody else to do the accounting for us. We take every transaction and we re-execute them. And here first, you have a first notion as to why blockchains don't scale. Because why blockchains are expensive. Because every time a transaction is done in the system, it is not done by one actor, it is done by all the actors in the system. Implicitly, a work that is done by thousands of people is going to be more expensive than a work that is done by just a handful, right? And another question to that is like, who here thinks that on their laptop, they're able to handle the load of Visa? Well, you might have a very big computer then, but other than that, I think it's really hard for you with a retail computer to handle the load of Visa, right? So blockchains give us really cool stuff, but we sacrifice things for that. We sacrifice scalability, we can't do a lot of transactions, and we sacrifice privacy, right? So that's why blockchain don't scale today. We talk about them as distributed ledgers. They're not distributed, they're replicated, right? Everybody is doing the same work. Now, I want to introduce a concept you may be familiar with, and it's a concept you can put in the same box as digital signatures or hash functions, right? They're tools you can use in your application. They're backed by mathematics. You don't have necessarily to understand how they work, but you can know how you can use them, right? And the way they work is the following. A validity proof allows Alice to execute a program and to send the output of such program to Bob along with a proof. Now Bob is able to take this proof, analyze it, and make sure that the program was executed correctly without having to execute the program. Simple enough? Well, that basically here is a fundamental paradigm shift in how computing works, because there is no other paradigm where you can give to somebody the assurance that a program ran correctly without him or her running it themselves. So this has deep implication for computing in general, but mostly for the blockchain world today, right? So ZK proof or validity proofs guarantee computational integrity. In our case, we don't use them for privacy, we use them for scaling. Why do we use them for scaling? Well, for a very neat property that these proofs have, which is that there is an asymmetry between how much work it takes for Alice to execute the program and how much work it takes to Bob to verify the program. The more work Alice executes, the less time it takes for Bob to verify it. Say it differently, Bob can execute a program on a supercomputer and Alice can verify the proof and use the output of the supercomputer in her application on her retail laptop without having to trust Bob at any step. Which is kind of mind-blowing when you think about it. It really introduces an asymmetry between these two players. So validity proofs are to computation what zipping is to a file size. This analogy is actually, it's good, but it has its limit in the sense that with recursion, you can actually compress further a validity proof, and you can't with compressing a file, but let's not get into it right now. All right? So far, so good. Now let's talk about how we apply this in the blockchain context. Let's talk about Starknet. So Starknet is a general-purpose smart contract platform that is based on that lives on top of Ethereum. It is secured by Ethereum, and the way it works is the following. You have a bunch of actors that are able to run a blockchain with transactions, with block, which is Starknet. And this blockchain uses a lot of resources. It is able to process a lot of transactions, like a lot. And you can scale this machine as much as you want because every time a block is processed, a proof is generated. This proof then gets sent to Ethereum and is verified there, meaning that Ethereum can take for granted that the output of that blockchain is correct without having to trust any human. And this is here also an interesting artifact. This is the only context. ZK rollups are the only context where two blockchains are able to understand each other. When you think about it, when you have WBTC on Ethereum, what Ethereum knows is that some humans say, yes, yes, we have BTC stored and we'll give them to you, but we have them stored, trust us, right? They rely on signatures. Well, with proofs, you can have guarantee that these funds are there, and you can have guarantee that what happened on this other network is valid. So let's talk a little bit about the lingo of Starknet, right? So you have a bunch of new actors. The fact that these validity proofs allow you to do that, to delegate execution to specialized actors, changes a little bit the topology of the network. It changes what it means to be a node. It changes what it means to be a validator, right? So in general, in ZK rollups, we have these actors. The sequencer. The sequencer is the entity that receives transaction and aggregates them in a block. It doesn't prove them. It just aggregates them in a block and calculates what is the latest state. The prover then takes these blocks and processes them to generate a proof that these blocks are correct, right? And this proof is then sent to Ethereum in a verifier smart contract. That's the beautiful thing also about proofs. It is a program, right? And you can write one in a smart contract. How crazy is that? So there is a smart contract on Ethereum that verifies Stark proof and is able to say, yes, all of these blocks were processed correctly. Now, what is a full node in Starknet? A full node is not necessarily a node that will store all the transactions, because it doesn't need to. It just needs the proof that the latest state is valid. So the full node will just store the state and give access to the data, to the application using it. And then you have Starknet Core. Starknet Core is another smart contract on Ethereum that manages the state of Starknet, right? Don't hesitate if you have more, if you have questions on that. So one thing I want to mention about Starknet is that if you followed so far, you understand that validity proofs are a fundamental new building block in the way we design blockchain networks. They have deep implication of what it means to be a node, what it means to run a validator, what it means to verify and not trust, right? They fundamentally affect the topology of your network, but also the way they're designed, they're based on mathematics, fundamentally impacts the programming paradigm in which your smart contract is used. So when faced with building a new solution on top of that, we thought, what should we do? Should we try to emulate what is happening on the blockchain right now, or should we try to leverage all these new advantages that this new paradigm gives us? And we chose the latter. We chose to build this network from first principle. We chose to optimize for speed, for performances, for security. So Starknet, first of all, uses Stark proofs. Stark proofs don't need any trusted setup. They're quantum resistant. They scale very nicely, and they're faster to prove, and they're better to prove big workloads. So they allow layer 2s to scale to amazing quantities. The second thing is Starknet uses a ZK VM. It does not emulate Ethereum. It has its own VM. This comes with a general purpose language, which is Cairo. I'm going to talk about it in a second. It is not a smart contract language. It's a general purpose programming language that is provable. And Starknet also comes with no backwards compatibility with Ethereum, so it allows it to leverage new innovations that come with ZK rollups, such as the ability to choose where you store your data, also known as how do you deal with data availability. It also builds on the shoulder of giants like Ethereum and takes good innovations like account abstraction and use them at the network level. And it also allows things like off-chain proving. It actually allows for distributed blockchains to exist, where work is done by certain entities and verified on the main chain. All right, so summarizing, what is Starknet? It's a general purpose layer 2 on Ethereum. It allows heavy machines to process the network and smaller machines to have mathematical certainty that they were not cheated without having to incur a big cost. Starknet is about scaling. It is not about privacy. And Starknet was built from first principles. It's optimized for this new paradigm that are validity proofs because it's worth it. All right, so now let's talk about Cairo, right? Because at the end of the day, my presentation is about Cairo. Where am I going with that? So what is Cairo? The first thing you have to know, without getting too much into the mathematics, validity proofs are a mathematical concept, right? And validity proofs are based on designing specific polynomials that represent specific programming, specific programs. Who here has already used CIRCOM, for example? A few. So if you use CIRCOM, you know that you have to define your program, and then it will define a circuit, and it will define a verifier, right? We went down that route in the beginning. We tried to write programs using specific polynomials, and then eventually we quickly realized that this doesn't scale. It's too hard, it's too long, and it's a bit less safe also. So we decided, instead of trying to craft a polynomial for each program, to create a program that can run programs, aka a CPU. This is the basic of what you have in your computer, right? A CPU is a chip that allows you to run any program. Well, Cairo is a virtual CPU that allows you to execute instructions that you can compile from a high-level programming language, and these instructions are in turn provable. Okay? So Cairo is a virtual CPU. It stands for CPU Air. Cairo, we also use Cairo to designate the programming language, meaning it's a high-level programming language that boils down to these instructions that in turn are provable. You can use Cairo just like you would use Python. It does not need to exist in the context of a blockchain. It's a general-purpose programming language. It allows you to write any program and prove it, which is extremely powerful. Now, if you've heard about Cairo, then you might think, okay, what kind of program can I do with Cairo? Well, you can write Starknet. The network I told you about before, it is all written in Cairo. When we say that Starknet, the network, is verified by Ethereum, it's because the whole execution of Starknet, the aggregation of transactions, the fact that the transactions are valid, that the blocks are valid, what is the state diff at the end, and what is the output, all of this gets proven to Ethereum. Think about it. How much work would it take for you to write a CIRCOM circuit that manages a full blockchain with state and smart contracts? Right? So Cairo is extremely powerful. It allows you to write blockchain software. Now, if you've heard about Cairo, you might have heard about Cairo 1, which was released recently. Who here has heard about Cairo 1? Maybe just a tweet or something like that. All right. So Cairo 1, so spoiler, in a few months you won't have to worry about Cairo or Cairo 1 because referring to Cairo will refer to Cairo 1. But Cairo 1 is the next version of Cairo. It's a more resilient, easier to use smart contract language. It has a Rust-like syntax. It comes with years of hindsight from running Cairo in production. It has gas metering and error handling. This is fundamentally a new change, a big change for Starknet, because it will allow Starknet to be more resilient to DOS attack. It will allow it to decentralize. It will allow it to be censorship resistant. But for most of you, you don't have to necessarily think about it. It's just a programming language, and you can write your smart contract in it. I want to leave you with one last thought about Cairo and Cairo 1, and it's the following. Who here has heard about L-freeze and fractal scaling? Enticing, right? You have your L1, you have your L2, and then you have your L3, okay? And it kind of makes sense. You think about it, there's a blockchain on top of a blockchain on top of a blockchain. Well, here's the truth. The space between L2 and L3 is much more continuous than it is discrete. I'll give you an example. I was last week with one person who did a POC for Yearn, right? And Yearn, they have a they have a smart contract to update their yield strategy. Currently, what happens is the governance will sign a message to say, yes, this is the new strategy and it is good. But Ethereum, the smart contract, has no way to verify that this strategy is indeed better, right? So what he did is he wrote a Cairo program, not a Cairo smart contract, a Cairo program that takes input from Ethereum, verifies that the new strategy is better, and then enforces it on chain so that it updates. And this right here is an example as to why L3s are a continuous thing. It's not a L2, L3, there's a lot of things in between. Some people will choose to run some of the computation of their app off-chain and verify it on-chain. Some people will choose to just aggregate transactions and then settle them on-chain. Some people will build weird constructions that are not blockchain but can still be used on-chain. You will have for the first time the ability to run code outside the chain and use trustlessly the output inside of the chain. That is a big, big paradigm shift in how blockchains works. And this is why it's worth it to have this construction, to have something that is not just meant to be executed in a blockchain context. All right, so summing up, why Cairo? Cairo allows you to create provable programs. Proof verification allows you to it allows a retail computer to monitor a herd of supercomputers and keep them honest without having their computing power. And Cairo allows you to execute any kind of logic off-chain in the same language that you would write your smart contracts in and use the results on-chain. Okay? Well, this is the end of my presentation. Can you raise your hand if you learned something? Nice. Who thought it was too easy? Who thought it was too difficult? All right. I think I'm spot on. So if you have questions, I don't know if you have a few more minutes, but don't hesitate and ask them. If you want to see what Cairo 1 looks like, check out this QR code. It will take you for a small ride. You don't have to write any code, just read it and solve puzzles so that you understand how Cairo 1 works. If you want to learn more about Starknet and receive educational material, check out the second QR code. It's our EDU newsletter. We send it once every 2 weeks. No bullshit, just cool stuff for nerds. All right. Thank you. And don't hesitate and come talk to me.
Yeah, we have a few more minutes for questions, so if you have any questions now, our colleagues will show up with the microphone. First here.
You're also able to scale the complexity of the kinds of programs that you execute. And I just wanted to ask if I'm getting the order of magnitude right. So for example, for distributed, decentralized video hosting, you need re-encoding. That needs to be provable. So you want to re-encode an uploaded video file, and you want to prove that you run this exact algorithm to re-encode it in a different resolution and so on. So is Starknet powerful enough to handle these kinds of volumes?
Pointing to a really cool direction, which is ZK Rollup allow you to do more of the same and to have cheaper transactions or to have more complex transactions. Now, is Starknet able to handle encoding? Right now, probably not. Also, you will have to rewrite all of this stuff in Cairo. But there's nothing like, eventually, the prover will be open source, not too far away from now. So you'll be able to encode your video on your computer and then verify the proof on the network. It doesn't have to be executed on Starknet, just verified. Does that make sense? Cool.
Right, we have time for one more question. And I assume Henri will be around afterwards for you if you have more questions. Just hit him up.
Thanks for the talk. I've been using the previous version of Cairo for a while, and I haven't been checked recently, but I remember a Cairo prover. So the Cairo prover were a proprietary backend service, and it wasn't open source. Like, what about Cairo 1? Will the Cairo 1 prover be open source something that, so we can generate the proofs on our machines locally?
That's a great question. So first of all, Cairo 0 and Cairo 1 compile down to the same CPU and the same set of instructions. So the prover will be the same for both. Okay. The prover is currently still closed source, but we announced a few weeks back that we will open source it. We committed to it, so it will be open sourced, and you will be able to run your own instance of it, or run a proving service if you like.
Okay, that's great news. Thanks.
All right. We have actually time for one more question. Henri, what do you think? One more question, the last one.
So I was wondering, like, when you have something like Starknet, what do you see as the source of truth for the transactions? Is it the L2 or the L1? Or then even if you have maybe an L3 on top, like, where is the real source of truth at the end of the day?
The source of truth is Ethereum, definitely. We delegate the security to Ethereum. That's the cool stuff about ZK rollups, right? They can live on top of another network and be secured by it. So there are different layers of finality to your transactions. First, it is accepted on L2, right? So there's consensus on L2. Then eventually, a proof is generated and sent on L1. This, at this point, is when your transaction is the most solid. So the source of truth is on L1. Interestingly enough, this is also why it's hard to connect a ZK rollup to various chains. But it's probably not unsolvable. And sometime in the future, we could have cool applications with that.
And do you think that also works if the data availability is not on Ethereum?
I think this is an open question, and I think that I don't have an answer, but I'm really looking forward to what each application is going to decide their security model should be.
All right. Thank you, everybody. Put your hands together for Henri. Thank you very much, Henri. All right. The next speaker actually wouldn't need any introduction. He's one of the most respected developers in this space, has been in this space for so long. I just got my phone here, so I make sure that I don't forget any of his titles. The next speaker is the implementer of the first complete ZK EVM proving system, rescuer of the DAO hack funds, paladin of open source Web3 tools, creator of Circom and Pill, Lord Auditor of the most complex smart contracts, leader of Polygon Hermes ZK rollup, first of his name. Put your hands together for Jordi Baylina.
Thank you, awesome, you're awesome. We need a clicker, I think, just to move. Let's see if I'm finding for a clicker, maybe this one. Let's see if it works. Yeah, look, works, perfect. Well, hello everybody, I'm Jordi Baylina. I'm the technical lead at Polygon ZKVM. As you know, we have been developing for the last year and a half, I would say even 2 years, from now on ZKVM. For me, a ZKVM is, well, it's a ZK rollup type 2, where it works exactly the same that Ethereum does. EVM is Ethereum virtual machine. That means that you should be able to take any smart contract the way it is and just throw it to the network, and it should work straightforward. You should not need any special tooling. You should not need any special compiler. You should not need any special wallet or anything like that. It's another Ethereum-like network. And this is what's ZKVM. That's this compatibility is what makes the thing so cool, that we can reuse all the ecosystem, all the tooling, and all the developments that are happening in the Ethereum space. We launched it 3 weeks ago. Network is up and running, and is the first of a kind in the space. So what I'm going to explain in this presentation is mainly what are the next steps. So what is going to be doing the ZKVM team inside Polygon for improving and doing the ZKVM actually to scale and to make it better. Okay? So let's start for some of the things. The first thing is that we want to be a type 2 rollup. Right now we are a type 3 rollup. That means that we are Ethereum equivalent on anything except that right now we need to implement some precompiled smart contracts that are not available right now. These are the SHA-256. This is probably the most urgent. Then it's Blake and Pairings. We are already working on that, but that's the thing that we want to, the main differences between Ethereum and a ZK-VM. Okay? Then we want to remove that ZK counters, more on that a little bit later. Okay? Second thing is we want to improve the prover. Okay? So right now, if we see the structure of the prover that we have right now, is a big proof where it has different state machines. We have the main processor. Here it's just, well, no, that's not probable. Not pointer. Well, anyway, so we have a processor. We have and some binary arithmetic, some Keccak, some auxiliary state machines, where you do most of the heavy operations. Okay. The problem that has while this is working well, the proof right now takes about 2 minutes in a big CPU machine to compute about 10 million gas. Okay, but the problem, so if you want to improve that, the big problem is that depending on the quantity of Keccaks that, for example, we can do in a proof is a fixed number, okay, or the number of arithmetic operations is a fixed number. So the idea is that we need, when we are processing some transactions, we need to count how many of these resources, we call these ZK counters, we are using, so that if we are getting out of the limits, we can stop the prover, say, okay, there is no space for the provers, and then we just do a no operation state transition. So we can prove that, in our system, we can prove that a transaction cannot be proven, so that this allows us, for example, to have forced transactions in the system. Okay, but this limit, having this limitation, what happens is that you are not using, a lot of the times you are not using all the resources. So there is a lot of, so maybe in a batch, if you have 2,000 Keccaks, and maybe you just use 1,000, but you still have polynomials for 2,000. So here there is a lot of waste in resources. So the idea is, instead of having a big monolithic proof, the idea is to create, using recursion, the idea is to have a proof with many sub-proofs. So the idea is to create a proof for the main processor, maybe a proof for the binary, and a proof for arithmetic. And this proof of the binary, the idea is that you can choose. So you have like 3 different circuits, one binary that's small, another it's a little bit bigger, and another is a little bit bigger. And then the prover, the recursion proof, the one that packs them all together, can decide which circuits you want to use. So with this, we can fine-tune very much fine-tune very much. So depending on the transactions that you are processing, you will use one circuit or the other. So we will waste less resources. According to that, the other thing, so this is good for when you have less resources, but the other thing that's interesting is that if there are some transactions that requires, for example, a lot of binary operations, the idea is that we can aggregate. So we can, instead of creating one single proof for binary operations, we can have like many proofs of binary aggregations, and we can aggregate all them together. Okay, so this allows us to have an infinite number of resources inside the proof. Okay, so the advantages of this is, there are many. The first is that this will allow us to remove, if not all, most of these ZK counters. So if you want, this is the equivalent of the gas somehow. It's the limit, the resources that you are consuming. So we don't have to do this accountability of these ZK resources, and then the system is going to be much easier at the ROM level. And the other advantages, there is a lot of advantages, is that right now, one of the big limitations in the system is that the prover requires a lot of memory. Right now, we are using 5 terabyte of memory, a server with 5 terabyte, which is a big server on there, because the proof is too big. Because if we are splitting the proof in a smaller proof, the memory requirements are going to be much smaller, and this will reduce also the cost of generating the proof. The other thing is that because the proofs are going to be smaller, then it would make sense to compute the full proof inside the GPU. Okay? And this will also accelerate a lot the generation of the proof. So this model of variable degree composite proofs allows us to be more flexible and to improve the timings and the latency, so how much long it takes to generate a proof, especially when we go to the GPU. Okay, next thing is, in order to support these things, we need to expand the PIL language. The PIL is the language that we use to build all the arithmetization of the ZKVM. So here we have some plans to extend the PIL language. I'm going to give you some highlights of the things. The first thing is to support this variable degree composite proofs. So while we adapt the language, so that each state machine we just say which is the subproof, and in each subproof we can specify different sizes, and then we can say that so that this subproof can be aggregatable. On that. So we can build PIL, and then the proving system should support automatically, should generate the proof or the composition of proof automatically from the PIL language. Okay, so that's important. Next thing is the constructive language. Right now, writing PIL, the PIL is very linear language. You just you need to put all the identities one after the other, okay? And what happens is in some complex state machines, for example, the arithmetic state machines, we end up like doing a secondary program that's writing PIL. It's like a kind of a script, a JavaScript script that generates PIL. So it's just and then this is hard to audit because you need this secondary program and the one that generated PIL. So the idea is to integrate, instead of having a separate script, the idea is to integrate that in PIL. So we'll have a programmatic, so you will be able to define constraints in a loop or with conditions. So this will allow us to do more complex PILs. In general, one of the learnings is that when you are working with Starks, it's more optimal if you go to many polynomials, so we call wider proofs and shorter degree, so small polynomials, many polynomials, smaller polynomials. In general, you get better performance, mainly because you have much less copy constraints in general. Okay, but when you work with many polynomials, that means that the number of constraints gets more complex, and then it's more necessary this programmatic way of writing these circuits. Okay. Another thing is the conditional constraints. This is more for a readability thing, but sometimes there is a lot of constraints that only applies to certain lines. Okay, so the idea is to use this structure, which is much more readable than the one that's in the old way. We also allow to define challenges. So if you check how the proof is done, mainly it's many steps. So you commit to some polynomials, you send a challenge, then you commit to other polynomials, you send a challenge back, and there are different stages. Okay. Right now in PIL, the idea is that you just define the first stage, and the others are automatic when you are using lookups or when you are using permutation checks. So you have access in the PIL only to the first stage. Here we are extending PIL so that you can define your own challenges and you can define polynomials in different stages. So this allows us, this will allow to generate other schemas for proving different things like equivalent, like lookups, but different schemas that they will not need to be required to be implemented in Peel. In this case, for example, this is an example how PluCap will be implemented using this. Actually, in current Peel, you don't need that because you just use the in directive and it's much shorter. But if you want to implement a different schema, then this should be possible. Okay. This is not constant. Here is the constant generations. Right now, when you are writing a polynomial language, a polynomial schema, actually you need to do like three things. One is generating the constants, the pre-computed polynomials, generating the Peel, which is the constraints, and then it's generating the witness or computing the trace when you are computing the proof. So you need a program to compute the trace. The idea is to put this step of generating constants inside Peel. So instead of having a separate program, you can put it inside Peel. This has a couple of advantages. The first is it's much more readable, and when you want to audit some of the circuit, you just need to go to Peel, and that's it. But the second thing is that a lot of the constraints are cyclic, and when you have cyclics, when you detect cyclics, then you can do some tricks to improve the performance of the prover. So having in the definition language makes a lot of sense. Okay. Also, in Peel right now, you can access only to the current row and to the next row to do the references, because mainly what you are doing is just state machine. But here we will allow to access to maybe many rows in front and many rows before. Okay, so you will have access, and this is much more flexible and much more readable. And that, of course, if you are accessing to many values, you will need to do more openings for each polynomial. But this is very convenient in some cases. Okay, and finally, we also have a special notation for range checks. Actually, we are doing range checks with a normal PluCap. But if you can define that in the circuit and you know that's a range check, there are other constructions. You can use other constructions that are more efficient. And a lot of the PluCaps that we're using are for just range checks. So we can optimize also a lot here in the range checks. Okay, so this is very much one of the line of works, is this Peel. The other important work in the ZKVM context is about compression. Okay, so right now the rollup is just sending the transactions in raw in the blockchain, but the idea is to compress this data. Data availability is going to be one of the bottlenecks at least in the short run. So the idea is to, instead of putting the transaction, is pushing a compressed version of the transaction. Okay, this is perfectly possible. The thing is defining what's the best compression. Okay. For compression, well, in general, if you see how compression works, in general, a compressed file is just a set of commands and parameters, and each command is just writing part of the file. Good example, for example, of these commands is, for example, write. If you want to write just some uncompressed data, you just print this or just output this and put this in the file. You can, for example, do a rewrite, just reuse part just go back in something that you write before and just write this again many times. Okay, but you can, when you want to compress transactions, you can do some special compression. For example, give you an example is, for example, for the values. The values, in general, values are typed by humans, and humans, the significant digits used to be quite small in general. So you are sending 1 ether or 3 ethers. You are not sending 1.5456738 ethers. Okay, so you can compress, you can use techniques to compress decimal values very well, and this will allow us to reduce a lot. Okay, but what else can you compress? The big important part is that in a rollup you can remove the signatures of the data compression. The idea is to substitute the signatures by a proof. So you are proving that you have, or the person that generates the proof have the signatures that thinks that. So you can replace all the signatures with a single proof that aggregates all the signatures that you are validating. This proof can be, if it's a Plonk, it's less than 1 kilobyte. Okay, and a signature is 64 bytes. So if you have like 16 signatures, it's more worthy to more than 16 signatures is more worthy to just put this proof instead of a single signature. Okay, and But if you see how a transaction is done, but there is one thing that's more interesting. And the idea is that for compression, if you want to compress the information, one thing that you can do is use, and here you can use the state, so you can use the current state to access the state to do some compression, but you can also have a system to access all transactions. For example, if you are sending an address, an Ethereum address is very difficult to compress by itself because it's just some 20 bytes and they are quite random. Okay, but if you can do a reference, you say, okay, use the address that's in, so use this data that was in this transaction that was 3 blocks ago and in the transaction number 10 and it's in the position whatever. This can be compressed as data compression very much and you can have access. And the access to all the transactions, to the raw data of the previous transactions, of the history of the rollup, this has the advantage not only for accessing addresses, which are very much compressed. It has also the access, for example, if you are accessing to the hash values of NFTs, or you are redeploying smart contracts that have very similar parts that you want to recycle, or you are accessing some Merkle tree where the hashes are the same. So you are using, many users are using the same Merkle tree. This is, for example, for the claim system. So this allows us to compress the data very much. We did some estimations. We expect that we can have a compression ratio of 5x. This is a little bit pessimistic, but so I think we can do it a little bit better. But this is the numbers that we are targeting. Okay, and if we add that, if we add that to the EIP 4844, that will give us 10x in the cost. That means that we expect that by the end of the year we can be a 50x scalability factor by the end of the year when you compose both things. Of course, working in this EIP 4844 is a priority. We have a special people that's dedicated to that from now on, and this is very important for scaling. For your information, this is the proto-dank sharding, but dank sharding, so when sharding happens, we expect that at least it's going to be an extra 0 here in the data availability. Okay, so this is a little bit the roadmap for this. Okay. Of course, having this, when you are scaling, is not only about generating the proof, it's also, you need to process these transactions, and you need to have all the tooling around, so the sequencer, the synchronizer, the database, so all the system itself needs to scale. So here is a lot of work also in improving the pieces to process that. I expect that the biggest bottleneck after data availability is more or less solved with dank sharding is going to be the transactions in Ethereum are quite sequential. That depends one on the other. Okay, so having a way to parallelize these transactions, there are some ideas and there is some people that's working in that direction, but this is probably going to be the next bottleneck after data availability happens. Okay. One thing that actually we are working, but we are not working, and one of the cool things of ZKVM, something that's opcode compatible and things, is that you have things for free. I mean, we have the EIP, so we have we have account abstraction for free. You know, account abstraction does not require anything in L2, so you can take all the account abstraction smart contracts, deploy it in the ZKVM. The same, you don't even need to recompile them, you just throw them and you have these account abstractions for free. Okay? This is a ZKVM, it's Ethereum, okay? So if Ethereum is improving, the ZKVM is going to be improving. If the Ethereum ecosystem works well, we are just going to get the benefits. We will have the benefits of the Ethereum itself, and we will keep the full compatibility. Just a couple of notes for this EIP. There are some optimizations, knowing that this is happening. There is a couple of optimizations that you need to take in account. It's like One is that the sequencer, if it's a centralized sequencer, it becomes very much as a the sequencer becomes very much like a miner. Okay, so you need to have some API for the CIP that you need to implement, but we will implement. And the other thing is also it comes more in the for the compression. Okay, if you want to remove the signatures of an account abstraction, you need to take in account that in the design protocol. So we are taking account that we can also remove the signatures from the account abstraction user operations or transactions that are happening here. But besides that, I mean, this is just optimizations, and everything should be in place on that. There is a full topic. This is something, well, we are to start working on that, is the decentralizing the sequencer. Just giving you some ideas here is you can understand the sequencer as a consensus. So you can replace the sequencer with a consensus layer. Right now, a centralized sequencer is a kind of a dictatorship consensus. It's whatever the sequencer is the consensus. Okay, so it's a consensus there. But you can replace this with another consensus layer. The idea is it's a temporary consensus because the sequencer only makes sense until the transactions are in the layer 1. But during this time, the idea is to change the consensus parameters in the trilemma. So the idea is that in general, you want a consensus that have a high finality with maybe sacrificing a little bit of decentralization and security somehow. And this is the idea is to adjust and having some consensus in there. So not in our team, but in Polygon, there is other teams that are working in that direction. And this is important also to mention. Okay. Of course, there is a topic of security. Security is it's the main topic. It's a priority in Polygon, so we are still doing audits, bug bounties, re-auditings, auditing the new code, and this is something important that we are strongly committed to this. So it's a non-stop work. Okay, and last thing that I want to mention is that we are thinking also in start increasing the trailing wheels. The idea is going to trailing wheels very soon. Trailing wheels, the type 2, according to Vitalik, type 2 very soon. That means in this stage, what it will mean is that if the system works okay, so the centralized, so nobody will be able to lock or, of course, steal the funds. Okay, so the system is going to be decentralized if everything works well. If invalid proof is detected or in some situations but needs to be proved in the smart contract, then the system may become, may halt and then that can be upgradable. Okay? For this, we need to enable forced transactions. We hope to do that very soon. We need to remove the security. Well, this is the forced transactions are already programmed. It's just a matter of hitting a button, but we want to, maybe in 2-3 weeks, I hope we can remove that. And then we have, remove the security conceal. That's removing the skill switch. That's another thing. And the last thing is increasing from 10 days to 30 days the upgrade time lock. Okay? This is a little bit the planning for this for the end of the year. We are very optimistic. As always, this is not a commitment. When you are doing these deployments, you can find things, but more or less, I think that this is where the timing is good. I think it's good to give times and for the people to know what's the internal timings that we are working on. So that's very much. Thank you very much for listening.
All right.
I don't know if we have time for questions or...
I think we're slightly running over time. Okay. But Jordi and his colleagues from Polygon, Anthony, are sticking around here. So if you have any questions, please feel free to reach out directly. You also seen Jordi's handle before. Great. Thank you very much. Put your hands together again for Jordi Bailina. All right. The next speaker is also working on very interesting questions. If, like the most of us, you're working in cutting-edge technologies, if you're working in uncharted territory, most of the time you can be a pioneer, a trailblazer, you can have the first mover advantage and you're incentivized to grab that advantage. But how do you juggle security and speed? The next speaker is going to show you a demonstration on how you can approach these questions or this conundrum. And he has worked in various roles as a researcher or as a software engineer in privacy or security projects. Everybody, please put your hands together for Anton Astafiev.
Hey everyone, here's the clicker. Cool. Hey everyone, I'm Anton. I'm head of security at Meta Labs, the team that is behind ZK-Sync Lite and ZK-Sync Era. But today we're not talking about layer 2 and which advantages rollups bring and whatnot. Today we're talking about how to build a secure system, build it fast, reach the market, get the adoption without actually compromising the security, which is a tricky question given that the novel technology usually comes with unobvious caveats that we cannot predict often. So a bit about my background. I've been working in different Web 2, Web 3 places, in development, in privacy, and security, some research, and so on. Most lately, I'm involved with different blockchain projects and doing security for blockchain. Basically, what we're talking about today is how can we align the speed of development. Everybody wants to move fast. The product team wants to move fast. Developers want to roll out their stuff as soon as possible, and at the same time taking an as careful approach as possible, doing everything that is in our under our control to actually protect the users, to not ship raw systems, to not really allow unsecure code to reach the production and to lead to a terrible compromise. Today I will be talking about how we approach this, and this is not going to be very Meta Labs or ZK-Sync specific. This is going to be more of a how to really juggle those priorities. So, very important disclaimer first. This talk is not for the people that are looking to cut corners. This talk is how to speed up the time to market without compromising on security, without cutting corners. If you're looking how to cut the corners, this is not the right talk. And a very important thing, if you are looking to ship the secure system, the audits and all the security measures will take quite some time. You cannot really shorten the time that it takes to secure the system. You can only juggle it in a different ways to reduce the time to market. So here's to our story. Our heroes are security team, development team, product team, and guest starring is the external auditors. Now, we're switching on to the problem, and this is going to be an overly simplified or slightly exaggerated conversation that I unfortunately have seen during my career several times. And the way it goes, the development team is like, okay, we're almost ready, the code is ready tomorrow, and then the product is like, yay, launching, 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 are the audits complete? And I don't even know where to start to explain that you cannot really have completed audits if the code is only going to be ready tomorrow. This is just not possible. Slightly exaggerating, but only slightly. This has happened in different forms and shapes, several times through my career. So, what can we do? In the worst case scenario, again, overly simplified, let's say we need around 2 years of development. Worst case scenario, at the end of the development, they're like, okay, good, we are ready. We're ready for the audits. And the auditor's like, yeah, you know, I'm available in a year. I think everybody's been there. And then the audits also take a year, and time to market 4 years, and the product team is like, what? And the investors are like, you said you need 2 years to develop the thing. Why are we now just speaking double the time? This is not what we agreed on, and what is going on here? So here we can start with a very obvious thing, like I think everybody is doing. We'll remove this waiting. This is the obvious place where we can cut. So we're eliminating the waiting time. There are 2 ways to eliminate the waiting time. One is pick whoever's available right now and just, kind of compromise slightly on the quality of the audit. This is not the recommended way. We really do not want to cut the corners. We need to engage early in a better scenario. That's where we are ending. This 1 year waiting time is then in parallel with the development, and our time to market is now 3 years, much better, but still not ideal. However, there's an asterisk here. What happens if the development is slightly overdue? And the development team was like, oh, we need another 6 months. You know what happens? Yeah, I'm already booked for the next year, so sorry, next slot, and time to market, and we're back to the worst possible scenario. So this is something that you need to be very careful about. When you're eliminating the waiting time, there are a few things to keep in mind. First, you need to pick your auditors, really know who you want to look into your code. Ideally, this should be the people that really understand what you're building, that have the experience with specific technologies, languages, and so on. And you need to engage early. You need to already, way beforehand, to be in touch with them and to see what their availability is. The second thing is you need to really have a good estimate of the development timeline, because if you are planning the audits 1 year in advance and your development is going to be delayed or completed faster, you need to adjust. So the other important thing is you need to, when you're already engaging with the auditors, you need to already know, at least in some form, the scope of the audit. It's not going to go well if you come to the auditors and say, you know what, we're building an NFT platform, or maybe DeFi. Oh, we actually haven't decided yet, but are you going to be able to audit it in a year? And you know what, it's going to take from 2 weeks to maybe 40 weeks. Yeah, TBD, we'll see. You really need to know what you're talking about, and this will also help you to pick the right people. And a very important piece here that many people forget is ideally you need to have some flexibility arranged with your auditors, because there may be last-minute changes, scope slightly expanding, things slightly delayed, or you're ready a bit earlier. You need to be aware, and you need to deliver this message to the auditors in advance and have the agreement with them, and ideally have a constant check-in with them. So we have signed, in a year we'll start the audit, but you know what, in 6 months we're going to have a check-in and see if we're on track. Are we actually going to be ready by then? Is the scope has changed? Has something different come up in the meantime? And these things are, the auditors will be also really appreciating, because they will be well prepared to really look into your project. But the question is, can we do better? Well, ideal scenario is the audit is ongoing at the same time as the development. Cool. And, well, now we're talking, but I feel like we already had this conversation. The auditors are really picky. They don't like auditing code that is constantly changing, and they really don't like auditing code that doesn't exist. So this is not an option. However, a very good question, are you building a monolith project, or is it modular? I dare say that in 2023, if you're building a monolith project and it's larger than a small pet project, you're probably doing something wrong, because modular development split into different components comes with many advantages, like you can develop them in parallel, you can test them independently, you can scale them independently. In a monolith project, you're going to have bottlenecks, and splitting them out and scaling them up separately is going to be very hard, and you will spend a lot of time on actually developing this and redoing your monolith into components. Upgrading is easier, and so on. So the general recommendation is split your system into self-contained components, which I think many developers are already doing, and build the most critical ones first. The thing is how that helps with our auditing approach. Let's say we have 3 components that we were developing in 3 years, and in reality it's going to be actually much more complicated. There are going to be things done in parallel and so on, but let's say we have split it into 3 main pieces and we're doing them one by one and they take exactly the same time within those 2 years, 8 months each. We engage with the auditors at the very beginning. We have waiting time kicked off 1 year, and we're building the first component, then we're building the second component, third component. As you can see, the audits have started after the components were completed, and we can actually truly and properly audit the code that has been fixed already, that has been stable already, and this has been completed already. So we can say, here's the repo, here's the commit hash, and the auditors will be able to say, this is the code that we audited, and everybody will be able to verify that later. Great. And as you can see, the development in total still takes 2 years. Nothing changed here. The audits total takes 1 year. Nothing changed here. Waiting, again, 1 year. However, the time to market is 2.33 or 2 years and 4 months. Great. So this is pretty much the main approach that we were taking. However, there is more to do here. You see there are like some gaps where nothing is happening. Can we fill in those gaps with something? But first, let's do the summary on the modular audits. First, build the most critical pieces first. Audit them first. You'll have more time to test them, run them on test nets, show to different auditors, run with the community, open source the code fully, and so on, and battle test those most critical pieces for longer time. Second, ability to move the starting dates and having this flexibility with your auditors becomes much more important in this case, because now you're not planning just the final delivery date. You're planning each milestone, and planning each milestone is much more complicated, and things may be depending on each other. And the most important part that you need to understand, this is going to cost you more. Not because the audits are going to cost you more, but because most likely, once you complete the first component, in our case, for example, this is the whole layer 1 smart contracts. You complete those, and you're working on something else that is interacting with those contracts. What will happen? You will realize some extra features are needed here and there, or some things have to actually work slightly in a different way, and you will have to update that code and make some changes into that code. Making those changes without auditing them is a really bad idea. This is exactly how a few well-known hacks have happened. Like, we had 6 audits of the code, but then we were hacked, and then it appears that nobody has audited the latest upgrade where the bug was introduced. So you will have to audit your first component and then do a bunch of diff audits, upgrade audits in the meantime, till you actually can launch. This comes with extra cost. It would have been cheaper for you to wait till everything is completed, everything interacts nicely, all your integration tests work, and now give it to the auditors, and they will spend 4 months, for example, on it, instead of spending 4 months on it in one run, and then 2 weeks here, and 2 weeks there, and 2 weeks there, and you're still paying for it. However, the price may be quite justified if we're cutting the total time to market by 2 years. Now, what else we can do? How can we fill in those gaps? Obviously, we want to do internal audits. Well, the reasoning here, auditors don't like to work on the code that is constantly changing. In-house application security, protocol security team is embedded in the development process anyway. They are involved at the architecture design stage already. I hope, if you're not doing this, you should. They are involved from the very beginning. They know what's going on. They know what the system is doing. They are participating in the design decisions. They are contributing to those. And they can start working on the code earlier, although it will be still changing. They don't need to acquire as much context. And well, it's okay. We are fine with actually redoing the audit. It happens sometimes that we are doing the internal audit, we highlight, like within a week, we highlight some issues, we come back to the development team, and the development team is like, oh yeah, good, thanks. We've spotted these two ourselves, fixed, we're not looking at the latest code. Fine, okay, happens. We do it again and again. We take more time, but that's kind of part of the job. And a very important caveat here, this is not, internal audits are not a replacement to independent audits. The whole point of independent audits is for the general audience, for public, to be able to see that somebody else but the team itself, that is financially motivated by this specific project, has done the research, has put the time and effort into understanding and has put their name behind it. Because the auditors, especially the most reputable auditors, their financial motivation, their incentives are with keeping their reputation clean, not with supporting any new rug pull. And this is the point here. The independent audits have to happen anyway, and they have to be done by independent, external, unaffiliated companies. Ideally, very strong auditing companies with very strong expertise. Another thing that we can do is public contests. In our experience, these contests yield amazing results, actually. We have received so many reports. We have improved the code quality tremendously. We received things like reports that are not security issues at all, just minor QAs, but all these tiny pieces together contribute to cleaner code base, better readability, and fewer bugs in the future. The incentives in those public contest audits are very different from the traditional audits. Traditional audits, they are paid per hour, they are looking at the code line by line. For the public contest, whoever reports the issue will receive part of the pot. And this will be shared with everybody reporting the same thing. So it incentivizes reporting unique things, unobvious things, opaque things, things that nobody else was able to discover. We've seen people trying crazy things, combining different approaches in different places that we probably would not be able to discover easily within the next 6 to 12 months, and then maybe 2 years later somebody actually would have realized how to combine all of those things together. By then we have huge TVL and it's a complete disaster. Those were really, really good. That's a really good experience. In my opinion, it doesn't replace a traditional audit, but combining those is really, really good. We did 2, we're planning to do more because we were very happy with the results. And finally, another thing you can do, and that's what we were doing as well, bring in independent researchers, not people working for big auditing companies. They're usually much more available. They are very skilled if you know where to look. And you know where to look because you just go to the top bug bounty programs and look at the top performers there. You go to public auditing contests and you look at the top performers there. What we do when we need to audit a bridge, we go to somebody who discovered critical vulnerabilities in L2 bridges and say, can you take a look at our bridge? We like spend a week, just look into the code. Not much code, spend a week, we'll just pay you. And maybe we'll not be publishing this audit because some of them want to remain anonymous. Some of them don't really have this kind of a publicly known name behind it. But the important thing for us is that we're actually getting additional value of people that will be breaking our stuff later via the bug bounty. And we just are getting a head start here. Another example for account obstruction implementation. The best you can do is go to the public contest on account obstruction, get the top performers, and ask them to look at your implementation, your design choices. So now, how this all combines together, this is getting more complicated, I see. In reality, it's actually much more messy because the components are not components. They are actually split into smaller pieces, all of them, and they're like interconnected. Things are happening in parallel, and juggling those things and making sure one thing is ready by the other is actually quite hard. But when we put this all together, at the bottom we have this very same weighting and auditing, the traditional audits. At the top we have the same development process. And in the middle we have like internal audit. You see it started before the components are completed. And it's completed slightly after. We actually, due to this head start, due to the spending time and being embedded in the development process, we can actually complete the audit within a couple of weeks after the development is done, unlike if we would have started right at the completion date. On the other hand, it takes longer. So if we start at the completion date, it takes 4 months. Otherwise, we need to spend 5 months, but we are done in 2 weeks after the completion. Pretty good. If you look here, like component 1, done. The audit, external audit is starting after the internal audit. Then the green ones are independent researchers looking into it. The kind of a bluish in between are public contests. They're all aligned well, and they're all happening and orchestrated in a way that the internal audit is completed after the component is done, and we indeed are sure the code has not changed. Then we hand it over to the external auditors, then we hand it over to, or maybe not complete, but at least critical pieces, some parts of it, to independent researchers. Then we have a public contest, and so on and so forth. And only the third component here is not fully covered by all of those things, but still, our results are, our time to market is 2 and 4 months, 2 years, 4 months. Every piece has been covered by independent external audit, as it should. We had public contests completed and fixes applied to 2 out of 3 components. We actually still have time to do it for the third one, for example. And independent researchers also additionally audited the most critical pieces of two components that we built. And now if we go back to the modular advice, start with the most critical first, which gives you more time to apply all those measures and to be much more confident in the code that you're rolling out. This is pretty much it. Of course, it's much more complicated. It takes a lot of planning. It takes a lot of juggling things around. But this is the gist of how we can do everything that we can to protect the systems and also to not to delay unnecessarily the public launch. Questions?
Well, unless there are questions, then thanks a lot for your talk. Or there is a question. Sorry, there is a question. Sorry.
You mentioned you are running public contests in parallel to kind of like the official audit firms. So how do you handle situations where during this public contests people find more bugs or issues than the officially hired teams?
So I must I cannot go back. They were never running in parallel. Traditional auditors do not like when somebody else is running a public contest, because if this happens, they are not going to look good. So this is why we're usually not doing it in parallel. On the other hand, for us, it's value in any case. We got the bugs reported, and we will fix them. The more the better, it's all right. We can come back to the auditing team and say, like, look, how did this happen that we missed it? Maybe we should actually improve somehow the documentation or the way we collaborate. But on the other hand, if the same things are reported from 2 different sources or different things are reported from 2 different sources, it's fair enough. We have to pay for all of it. If at the same time, the same code is in the bug bounty program and this comes through the bug bounty as well, and it was not a known issue at that point, and then we get it from the auditors later, well, c'est la vie, we have to pay. And to be fair with the community, we have to basically stick to our commitments and just hope that they help us to discover everything that is possible.
Thank you so much. So next up, we'll have a forward-looking topic with the name of DeFi the Police. The speaker is a musician, a passionate linguist. He's also Spaghetti organizer, and just as I mentioned it with Maria, this is another one-person Italian powerhouse. And unless you have this guy at your conference, you don't really have a community conference. So please put your hands together for Matteo Zambusi.
Hello, can you hear me? Okay, just check if the slides, perfect. Again, my name is Matteo. I work in Stake Capital for the Herd Studio, which is a new entity, along with Rect, creating content and some designs. I'm also co-organizer, as Josef was saying, of Spaghetti. And I have started this idea called DeFi the Police with a first talk that I gave last year at ETH Prague So please give a big applause to ETH Prague people and Duct Tape Production for always putting things together in a very, very nice way. And since then, I'm kind of adjourning, updating this talk with sort of open source feeling with people who want to join this research independent effort. So why decentralization? Short recap. We need definitely more inclusive and transparent financial system. We know that we want to free the economy and the system of measurement of value from centrally governed currencies. Also, this is something that didn't touch only crypto, but along with crypto, we saw in 2008 the rise of local currencies. So very analog currencies. In France, there were like 120 currencies by 2010. So the 2008 crisis triggered many, many different movements. We definitely need decentralization for a more democratic and redistributive internet. And also, we need decentralization and decentralized technology to implement public goods out of their systemic obsolescence, heavy bureaucracies, and monopolies. So the question is, security is a public good. Can we afford an obsolescent security public service? The idea of defy the police started with the Black Lives Matter movement. You saw cartels like this in most demonstrations, and actually this movement led to some implementations in some police departments. They tried to defund the police with very bad results. And so the system have been evolving around this idea, and I am proposing here a few verticals. So the objectives of this talk are to start the conversation around what I call the centralized management of violence, which is different from the monopoly of violence. I personally refuse the idea that violence is a marketable commodity. So I would like to stick to the management of violence. We will explore the field and trace some use cases, candidates for decentralized technology, and present some examples. So some disclaimers. There is no derogatory intention. I think that we do need some level of management of violence at a centralized level, but we'll see how that works. And the management of violence is a vast field that changes by country, by the number and diversity of the forces deployed, and local issues. The police in Honduras has different rules of engagement than the police in Milan, for example, okay? And I have based this research on interviews to people working for the Italian military, for the Italian police, and professional working for NATO. So take it with a grain of salt, but this is all, of course, confidential by the Chatham House rules, information that I retrieved by these interviews. So security forces, a few brief description, they obey, that's what they say, they obey the constitution, or better, they abide by constitutionally elected representatives, which we know in most countries, they don't have the mandate of electorate. So that means that once you vote for someone and that person gets elected, they have all the right to switch party the very day after. We need security forces. Security forces keep citizens safe from what is called the social alert. I will explain later what it's all about. They are funded by taxation, but again, taxation and funding are brokered by centralized governments. And their financial operations are strictly tied to the monolithic system of command hierarchy. So we need security forces for what? To fight organized crime, to guarantee national and public security, to manage traffic, streets order, to coordinate the population in case of natural catastrophic events or other major force majeure events, and to guarantee infrastructures. We don't need them to declare a state of war against the citizens' will, to use suppressive rules of engagement. ROE here stands for rules of engagement, not return of E. Maybe that's another acronym, sorry. We don't need them to use suppressive rules of engagement on demonstrations. And we don't need them to execute orders against the freedom of speech and press, freedom of movement, identities rights. And we don't need them to seize infrastructures, just like it happens in some Central African countries. When they are close to election time, they just switch the internet off for maybe weeks. And also use surveillance technology against the citizens without a reasonable cause. Security forces need secrecy for investigations, of course, to define targets, to run operations, and for on-field communications. But they also need transparency for the chain of command, who takes what command and who passes on which command and who executes which command, for accountability of that command and execution, for order formulation, and most important, for budgeting and spending, which is very opaque. There are certain bugs in the management of violence. First of all, the centrally determined supply allocation is not efficient. In Italy, for example, this is just an example, the police supplies have 2 seasons, winter and summer, regardless if you live in Sicily or in Tyrol. So if you have to change your equipment in October, in Sicily there might be 35 degrees, in Tyrol there might be 10 degrees. But you have, as a policeman, you have to change and take the summer clothing or winter clothing. And there are doped contracts, the famous 10K toilet being supplied for especially military operations. We know that the war is always a big reconstruction and this sort of camp facilities market. So there are doped contracts, poor qualities of supplies, there are many conflicts of interest, so high hierarchy generals recommending certain firms. And there's also what is called accounting, a problem in the accounting of what is called asset forfeiture. What is that? Asset forfeiture is like when I enter, for example, a drug dealer's place and there are some cash on the table, maybe 10K. I declare 5K and the other 5K I just just pocket them with my colleagues. That happened. That happened in the US. That happened in Italy. As long as my research moved on. And centralized communications can be hacked and manipulated. We know that there is a long bureaucracy behind passports, visa, which is mostly due to obsolete bureaucracy, and the social alert. So every government issues what is called the social alert. The social alert is basically a series of KPIs that every police department have to reach in order to get bonuses and further funding. For example, in Italy, in the Carabinieri district of Piacenza, they hacked the current KPI because one of the KPIs was number of arrests of a specific target of people. So they kept arresting and releasing the same person, of the same people over and over again, just raising their score and receiving a lot of funding. That is basically creates a system where the police is more interested, the management of the security is more interested in the responsiveness rather than in the preemptiveness of their policy making and actualization. So that's what many cops told me. We do not have enough incentives to work on preemptive policy making, which was kind of a revelation to me that a cop could say that. There are also some gimmicks in the management of violence. First of all, orders must be executed unless they clearly constitute a crime. But again, this praxis is very unincentivized because you have to go through long bureaucracy, you have to expose yourself as a public officer. That means that you are more likely not to career up in your life. So there are a lot of disincentives. The source of legitimacy of a given officer doesn't always follow the hierarchy. So if, as an officer, you are in charge of a specific premise or action, you can outrule a higher rank if you are, the direct in command for that. The rules of engagement for the police are mostly established at local level, which is usually more flexible, like the town hall and region, which is usually more flexible than the central government. And in certain cases, by locally governing institutions. Like, for example, in stadiums, is the FIFA that says what the police can have and cannot have. For example, in stadiums, FIFA clearly says cops should not have tear gas. So whenever tear gas happen, those cops incur into trials because the rules has been set by FIFA and not by the local government. We also have more measurable than before because we moved away from the old paradigm of military objectives equal deaths per mile. So we also, if you look at YouTube, we have more and more channels of police departments or military camps where they do memes while running, etc. So there is a strategy to get the security forces more public friendly. And also, this goes within what NATO established as the PSYOPS conference in Tampa in 2016 as an attempt to implement more social networks adoption from the security forces side. There are already some intersections between security forces and blockchains that are exploring, of course, audit spending, supply chain tracking for components, a decentralized database for passports that happened already in Dubai with a partnership by Hyperledger. There is, again, on Hyperledger, a project run by the Department of State. DARPA stands for Defense Advanced Research Projects Agency. Basically, they are looking into forward and backward secrecy for messaging, live self-deleting messages, one-time eye-only messages, and resilience against cyber attacks. And again, NATO is pushing a lot towards this innovation challenge to operationalize the use of social media and use blockchain-powered procurement in their operations. We move into proposals, and I would like to start this part with, with this sentence by Norberto Bobbio. Norberto Bobbio is one of the greatest political philosophers of our time. He said that a democratic country is mature when the armed forces are perfectly integrated in the civil society. So let's see what... This is a first proposal that I found by Kixoneal and Spector, already dated 8 years ago. It's about neighborhood security. So basically, it's a peer-to-peer business relationship between the customers, meaning the tenant, the people living in a given neighborhood, and the patrolling guards. So there is an individual relationship between the householder and the patrolling guard. The customer, the tenants, do basically confirm their own ID by doing a proof of burn of cryptocurrency, and they receive this RCF, a random coin fountain, which is basically placed by the house, and which is lottery-based. So the more checks it receives from a patrolling guard, the higher the chances that patrolling guards receives a drop, an airdrop. Okay, so it's a random coin fountain. The reputation of the patrolling guards is connected to the tenant, meaning that me as a household, I like this person, he's coming quite often to check up, etc. So I just boost him up, boost her up, and that will give him, her more chances to win the lottery out of my fountain. And I can also do the opposite. There's also a call for help broadcast that basically all of a sudden boosts up my random coin fountain possibility, so I have all the guards coming to my house to check what's happening in case I'm afraid someone is breaking. Okay, the problem here is that this system is a lucrative model that basically encourages gated communities to become even more gated. So if you don't have the way to incentivize people to go and check your houses, you're basically left in the wilderness of criminality. The one proposal that I'm kind of very softly carrying on is to work on that definition of KPIs. So the idea that, of course, it's an open source idea, and you're welcome to join a Telegram group later to propose what you think is a good way through, is basically that the public administration could issue SBTs based on an advancement of what is called the indivisible taxes, the TIS. The TIS in Italy, for example, are those taxes that you pay for streets cleaning, for light, and for the police, for security. So by advancing your next term taxes, you receive this SBT, and that taxes go into a matching pool altogether. Citizens can group into delegations, like, for example, NGOs. Who was in Bogota at DevCon? Thank you. Like in Bogota, for example, there are many NGOs working in the streets, taking away kids from street gangs. So they know the reality of crime. They know where crime has its roots in. They can formulate good preemptive policies. So the idea is that we want to empower those NGOs to propose this bottom-up KPI thinking, strategies to prevent crime issues, and citizens can basically vouch their SBTs for a determined strategy. Police stations can basically allocate or stake their officers' IDs to certain strategies, and this delegation can say, okay, this cop is actually doing a good job coming in here every day, working with us, etc. So we boost their reputation up, and that would basically mean more threshold out of the matching pool being destined to that particular department, police department. Yeah, so basically these funds are split among strategies with the best vouching performance. That's basically it, but onboarding the police, am I out of my mind? It's a hard thing, It's even hard to, onboard Generation Z. So why the police? But actually, they have been onboarded already by people like this. Hyperverse was a big scam recently happened, and in Italy, they had one of their promoters actually being some people in the army and in the police. So we had a lot of policemen and policewomen scammed by these because the network was in there. So they know what's crypto, they know how to handle wallets. So they got burned, but so I think that many people as well did here in this room at a certain point. And this is the Telegram group if you want to join the conversation, if you have some thinking, if you bump into some news that could be interesting to share. There are some interesting profiles there from different projects in crypto that want to put their thinking in. And I will share these slides on the Telegram group. These are literature, etc. And I would like to end with wishful thinking that we should drop prejudice. There are good cops, there are bad cops, of course. And the only way we can have social peace is through justice. And the only way we can create a better justice system is by working on good administration and good finance. So that's basically my presentation. If there are any questions, I'm very happy to take them.
All right, thank you very much, Matthew. We have time for one, max 2 questions, if there are any questions.
Thanks for the presentation. This is a really interesting perspective that I hadn't thought about as a use case for crypto. But I was thinking a little bit about what you said about the use case for local groups in Bogota, for example, that you talked about, where they can also contribute to the policies and, I guess, different KPIs for the police. And I wonder if this is something that you've already, I don't know, tried to roll out in specific areas, or what do you think could be effective KPIs for police organizations or government violent organizations in, in practice?
Ooh, well, that's actually, I still haven't thought about it, but that's some cops gave me some very interesting answers, and I should go back to the interviews to see those answers. But I remember that those cops were really into providing a system so that there was a sort of like, okay, the judiciary system benefits, for example, for this corrupt KPI system, because the more trials you have, the more lawyers have to be. So there is definitely something that cops told me. So it's not just about the government and the police. There is also like an economic triangle there, the judiciary system, which has also its lobbying, etc., that supports that policy, because that means more work. And so, for example, yeah, I would look into that triangulation in order to maybe achieve the direct line. Sorry if I didn't give you direct answers, but yeah, actually, please suggest something. I mean, and that also depends on the area where you're in. I think if you have to deal with drug problems or gangs or youth gangs, so there are many different problems depending on the area, suburbs, etc. Thank you.
All right, put your hands together again, once again for Matthew. Thank you.
I think I was stealing it.
That's straight to the cops. Try to steal. All right, the next speaker, he has 2 very interesting points. I'm sure more than 2. One is his last name. He shares the last name with one of my favorite movies. And the second is he's working on highly important, very interesting questions. You know that feeling when you download a file, you put it somewhere in a folder, and then you need it again, and you don't know what the name of it is, and the data isn't available? Now think about this, but on distributed ledger. The next speaker, Victor Tron, he is the founder and team lead of Swarm, and he's the president of the Swarm Foundation. And with Swarm, they're tackling questions around data availability for the Ethereum ecosystem. Everybody, please put your hands together for Victor Tron. Not yet? Oh, he's not here? All right. So, what have you learned today? Anybody saw an interesting talk today? All right, he's here. Victor saves me. Great. Everybody, put your hands together for Victor Tron.
I don't know. Likely not. Likely not.
It's okay.
You want to be here or in front? Up to you.
I just want to be able to see the notes.
Yeah. Okay. Does he have the laptop? Clicker is here.
Okay. Fantastic. Hello, everyone. Thanks for coming to my talk. Can I start? So this talk is about data availability. Or is it really? In recent years, this term was used to refer to the problem of persistence and retrievability guarantees of sidechain transaction data, in particular, and most relevantly, data transactions submitted to ZK rollups, which state validators of rollups need to reconstruct the state. But my talk, please go back. But my talk wants to broaden this context, admittedly, and maybe provocatively, hijacking this consensual, narrow meaning somewhat. When the founders of Ethereum recognized the Turing-complete blockchain as a layer of global secure computation, they started imagining what a complete computation environment would look like, an infrastructure underlying the new re-decentralized internet that they termed Web3. Who remembers the word computer here? Components of this architecture, of this infrastructure, were conceptualized using the analogy of computer hardware. The Ethereum blockchain being the CPU of the word computer, they envisioned the hard disk for data storage, called Swarm, and the messaging layer, called Whisper, referring to this as the holy trinity of components. For various reasons, manifesting this greater agenda proved a much harder nut to crack and subsequently fell out of scope for the Ethereum Foundation. Nonetheless, research and development in this direction never stopped. So the ambition is to realize the serverless internet, and the data layer serves this purpose. Go back, please. Back. In this context, a complete future-proof base layer infrastructure, a data layer serving the Ethereum ecosystem, does not only have a wider scope of uses on its agenda than the term data availability refers to, but also must deal with the requirements going beyond what is subsumed under this narrow sense of data availability. These aspects include representation, permissions, and persistence. The first concerns what form is the data accessible pertaining to units of data, units internal structuring, linking blobs to each other, and categories of content. In more familiar terms, it is concerned with chunking, addressing, mutability, and searchability of data. The second aspect is concerned with privacy aspects. Who can access the data and who knows who can access it. In more familiar terms, it is concerned with encryption, access control, censorship resistance, and plausible deniability. The third aspect is concerned with how long can we access the data and how certain can we be that the data can be accessed. Now let's look at some of the major use cases of such an ecosystem-wide generic data layer, and formulate requirements based on the needs of these use cases. Starting with what the data availability is in the narrow sense is concerned with, support for blockchain-related data. Secondly, the problem of hosting application code and associated static assets. Of course, don't get confused. This includes JavaScript or WebAssembly code that is driving dynamic pages of the application UIs. And thirdly, personal and application data. However, we must not stop here. Being a generic data layer with the objective to power Web3, we do not only include storage of data, but need to take care of distributing, transferring, querying, and discovering data. If we go the whole way and ambition to implement the serverless internet, we need to tackle the functionalities that in Web2 are carried out on the server, namely carried out by server-hosted databases, server-side processes, and server-mediated communication and notification subsystems. This is no small feat. Let us zoom into these use cases and formulate some requirements they impose on the data layer. First of all, let's look at the blockchain-related stuff. We can regard the blockchain state snapshot, for example, as a baseline since it has no special requirements. It is public, it is only auxiliary data to help synchronization or quick bootstrapping, and therefore has no requirements on data availability. This contrasts with transaction data for rollup support, which are strictly needed for state validators, and therefore have strong availability, as well as low latency retrieval among its necessary requirements. Mainchain state support is an interesting case because it raises the possibility that the native representation of Ethereum state, namely in the form of Patricia tries, maps directly to the distributed storage representation, namely blobs of data corresponds to serializations of the Patricia trie nodes, and the content address links are kept intact, and therefore it opens the possibility of querying the Ethereum state by traversal in the distributed storage system, and therefore potentially providing decentralized alternatives to centralized providers of endpoints like Infura and Alchemy, or support for light client requests, or even decentralized blockchain explorer. Now, hosting dep code raises a whole different concern about usability. First of all, it requires, as we talk about browsing UI, it requires URL-based addressing from the data layer. This can be described as a mnemonic reference to a collection and a path-based reference to an asset within the collection. The former already requires mutability and can be solved by ENS resolution on the blockchain, and the latter requires representation of a collection and index lookup support. Importantly, application code raises privacy concerns. Ideally, accessing a Web3 UI should not leak the user's identity, and therefore requires requester anonymity, and also, really in the spirit of true permissionlessness, making available a Web3 UI must not be leaking the identity of the originator. Just think Tornado Cache here for a second. Thirdly, serverless data support should include searchable structured data, necessitating sub-ENS mutability because of quickly changing data sets, optimized updates, optimized structures optimized for updates of structured data indexes, potentially historical persistence, and of course infinite scalability. Let's go back. But most importantly, if you also want to encompass communication and notification subsystems, these are harder not to crack, and there's not often that currently existing solutions offer a solution for these problems, namely communication and notifications. So let's go ahead about the commonalities between, go back please. Let's talk about the commonalities between existing active projects that try to fill this gap of a generic data layer in the crypto space, or something similar to that. They all share the idea that the network, that this emergent behavior of this data layer is ultimately implemented by a peer-to-peer network, where the peers use some sort of underlay connection pattern, but also usually use an overlay connectivity and topology to make routing efficient. Referencing to blobs of data through content addresses is a common choice because it already serves as an integrity solution, but is usually combined with a model where you can place the participating nodes in the same address space as the chunks themselves, and therefore you can use the overlay topology to allow efficient routing to nodes that store information about chunks that are close to their own address. They differ, however, in their storage model, which are now simply call either stewardship-based, as in the file sharing type of paradigm, where you open up your hard drive and register whatever content you have on there, and let leechers become seeders, or the direct storage model, in which I call address-based storage, when the neighborhoods of a particular proximity hold the actual chunks that are close to them. So they do not always serve location information about those chunks which are close to them, as for example, a BitTorrent tracker, but actually store the data. Now, in terms of persistence guarantees, we can mention 3 types of solutions, namely redundancy, stewardship, and the incentives. So redundancy is concerned with can be interpreted as replication resilient against the percentage, a particular percentage of data loss, remedied by local or cross-neighborhood replication. And most efficiently, however, in a distributed way, using error correction codes. That is information theoretically the optimal way. Stewardship here refers to a few things. Here I refer to stewardship also in the sense that, for example, the file sharing type of systems have the origination of content based on stewardship, since they make the entire semantic content, like the entire content that's semantically relevant to users in full from their node. And also replication is also done by its consumers. And therefore, it leaks information about the originator, and therefore kind of is not compatible with censorship resistance per se. This is also true if insurance is based on a kind of marketplace, because there also it leaks if the insurance is provided, that is by the insurer, if the storage is provided by the insurer, it exposes them and make them susceptible to targeted attacks. Now, incentives. Positive incentives means that not storing the content gets rewarded upon showing evidence of entitlement. So they prove the retention of data and with recency and relevance, but they have no punitive measure associated or implied if any particular piece of content gets lost. This contrasts with negative incentives, which essentially is insurance of particular content. In case of negative incentives, insurers sign up on a collection, and in case any chunk gets lost or goes missing, the insurer can be challenged and stand to lose their deposit they staked. Most systems where storage incentives are primarily in the form of a marketplace, providers, both the collection and the originator, and the issuer all leak the identity and therefore provide an attack surface and raises privacy concerns. We argue for a solution where the primary mode of storage incentives is just positive incentives. More about incentives, please go to Daniel Knight's talk tomorrow at 4:20 when he's talking about the incentive system implemented in Swarm. So now I'm going to arrive at the time. So now I arrived at the most important part of the talk, which shows the takeaway message here is that although decentralized storage solutions are quite similar in some ways. So they share a lot of commonalities, which would lead you to think that any further specific details about architecture is just an implementation of detail. I'm going to argue otherwise, and I'm going to argue that low-level architectural choices have major consequences on the requirements, and might be not only sufficient but even necessary requirements to satisfy some of the requirements that I identified in the first half. So, give me a second to breathe. So, address-based storage. So address-based storage, as I said, means that chunks are directly stored at the place with nodes whose address is close to their content addresses. This implies that there need to be a protocol where content is uploaded and chunks need to be routed to the neighborhood that they belong. And this already shows that this solution provides a proper cloud service and not only presence like the file sharing solution. And this allows for users to basically upload and disappear. So use the storage solution as a genuine cloud service. Most importantly, it contrasts with stewardship-based approach, where storing the file is kind of, if you're looking at your local storage, it leaks information about the originator, and therefore it is not censorship resistance. Address-based storage provides local redundancy right away from the start, and most importantly, incidentally, actually not most importantly, but incidentally, it comes with a bonus that a constant upload of chunks provides a cover traffic for address-based messaging. What is address-based messaging? Address-based messaging is when you send a message to a node address, and this is typically used for scenarios where you have to establish a communication channel with someone as a recipient you don't know. This is basically the solution for spamming or send anonymous messaging. So the primary insight here is that address-based messaging thinks that messaging is secondary to storage, although on first look it looks like it's just involves routing, but in fact if you make it parasitic on chunk uploads, you can hide the messages in so-called Trojan chunks, which are first for any third party indistinguishable from an encrypted chunk, and therefore can only be opened by the recipient themselves. On top of this, it inherits all the properties from storage of chunks, namely incentivization, asynchronous delivery, and cover traffic to mitigate against traffic analysis attacks. Now this is the most important slide probably. So we mentioned that peer-to-peer networks use the underlay transport protocol and the corresponding connection type and an overlay topology for routing. However, if one chooses a keep-alive connection, it has an immediate benefit that you don't have to establish a new secure channel for every request, and the peers that you select, you can be sure they are online. Most importantly, this enables request forwarding as a type of routing, which is in contrast with iterative routing. Iterative routing is when you iteratively ask your peers to give you closer and closer peers to the destination address, but you directly contact them. this leaks the identity of the requester. However, relaying or request forwarding leaves the requester ambiguous and therefore allows private browsing and censorship-resistant uploads. Also due to the fact that in case of retrieval, the chunk data travels back along the same path as it was forwarded, as the request was forwarded. It gives the opportunity to forwarders to opportunistically cache the chunk content, which is, by the way, incentivized by bandwidth incentives. And this kind of miraculously takes care of automatically scaling popular content. So you don't need seeders become leechers type of thing, but it's kind of a very similar effect. So the most important innovation that I want to introduce is single owner chunks. So we talked about content address chunks so far, which owe their integrity to the irreversible nature of the hash function, because their content address is based on hashing the content. However, single owner chunks implement their integrity by the attestation of their single owner. And this allows for constructs where you have a predetermined address where you can put arbitrary content into. And therefore, someone can kind of follow an address which is by convention so-called rendezvous point for someone to leave a message. This allows for genuine communication channels to be established, and if you implement sequences of conventions about sequences of predefined addresses, it can implement feeds, which are good for solving sub-ENS mutability, as well as version tracking and all the rest of it. Finally, erasure coding, if cleverly defined, once more, relatively small chunks, then any reasonably sized asset, if it's downloaded in full, can be erasure coded. And it does not only provide the benefit that is normally associated with erasure coding, which is increased data availability and higher certainty of persistence, but it also allows for masking the network contention errors of a percentage of chunks, or even Kademlia connectivity gaps in your routing table. And therefore, it puts an upper bound on retrieval latency, quite surprisingly. This is all. And I will conclude by saying that what I talked about, the takeaway message is that if you want to implement a generic data layer that is in alignment with the original ambitions of the Ethereum project, namely a generic data layer underpinning the really decentralized serverless World Wide Web, then we need to meet certain diverse requirements. I argue that some of these low-level choices are not inconsequential. They actually have far-reaching consequences in terms of the satisfiability of these requirements. And in fact, I argue that Swarm has the features that allows it to comply with these requirements. And in fact, in some of the features at least, my claim is that these features are not only sufficient, but in fact necessary. This strong claim, of course, needs a proof, which goes well beyond the scope of this talk. Anyway, so I leave you with the message that the idea of the world computer lives on, and if this generic data layer gets in production with full features and secure operation and proper unspoofable incentives, then we can prepare for the next big thing, where the original dream of implementing decentralized eBay, decentralized Uber, all you can eat, etc., can be finally implemented. Thank you for your attention, and feel free to ask questions.
All right. Thank you very much, Victor. We have time for a few questions from the audience. So if you have any questions, my colleagues will come up with the microphone. Oh, there's a question up there.
Hi, first of all, thank you so much for the talk. I had so much fun looking at those images that I could barely focus. They were so pretty. My second question is, if you imagined a world where data access and the interaction with a blockchain type of application could be in the hands of the many, in the hands of every one of us, what would that look like in practical terms? And I know it would be an oversimplified answer. Much appreciated. Thank you for your time.
Well, I have quite an ideological approach to answering this question, but I try to be as neutral as possible, because it's part of our credo that as a base layer infrastructure, we should be content neutral. But in the world where this is possible, I think what I call the 4 F words can be mitigated. The 4 F words are basically various aspects in which freedom and fairness has an obstacle. These F words are force, fallacy, fraud, and friction. And with basically a secure layer that enables free trade for data economy at least, of course it can never claim to be relevant for your local baker directly, but things that can be censorship resistant proper, which is ever more proportion of the real economy. If it implements ways in which the barrier of entry and the availability of barrier of entry decreases, and the availability of productivity tools and tools that you need for conducting business and finding business relationships is kind of trivially available and cheap, then you can expect all the benefits of free trade, which is the obviation of the need for state control and, in general, centralized control or any kind of stupid regulations. And secondly, as a consequence of the resulting closely knit social network on a planetary scale, it's a conduit for world peace, no less.
Thank you, much appreciated.
Are there any more questions? All right, I'll hand this over to the right MC.
All right. Thank you very much again, Victor. Put your hands together for Victor. All right. I assume we have a few apes in here, degens in here, aping into different DeFi protocols. Who's aping in like the first 10, 15 minutes after finding a protocol? My guy over there. This is the great returns. As you interact with those these different DeFi protocols, especially the ones working with perps, options, synthetics, You are probably very happy about that they have a very available, that they have a single source of truth when it comes to data. In our next talk, we'll see the disruptions and happening in the Oracle space. And these disruptions and innovations in the Oracle space will be explored together here with the next talk by our two speakers, Marcin Kazmierczak and... I'm very sorry, Jacob. This just came in very new a few minutes ago that we have a two speaker. Jacob Wojciechowski. Great, put your hands together.
Okay, 1, 1, 2. Okay, I think you can hear us now. Hi guys, thanks for having us. In front, you mean? Okay, so thanks for having us. So my name is Marcin, and I'm COO of Redstone and also co-founder of ETH Warsaw, which is a conference in the hackathon in Warsaw, Poland.
And I'm Jacob, the founder of Redstone, but also with a technical background. So I'll be dealing with the boring stuff, and I let Marcin to introduce you the topic.
Yeah, so you always have to have someone that deals about the boring stuff to create value, right? And then the other guy that is capable of presenting a little bit, maybe. So today we're going to talk about stateless oracles. As we got introduced, like oracles is this weird concept that many people think they understand, but maybe on the surface level. And there are many caveats when you dig into that we will try to break it down. So maybe to start, so that we are no strangers, we as Redstone last year raised $7 million as our seed round from notable Web3 investors. It's just to show you that not only us, the builders, but also investors see value in opening up the Oracle market and innovation over there. Our product has been used on many hackathons last year. Altogether, I think 5 prizes across 5 different hackathons were distributed using our technology. One of them was Lens Score. So using our Oracle, we aggregate data from Lens protocol about the score of a given handler, and then we can provide it to your smart contract so that you can create, for example, anti-bot or like a system for rewards or anything similar to that, which shows that finally Oracle delivers not only pricing data, but it can be any arbitrary number, right? We talk with developers. Like, it's not like we close ourselves in a garage for half a year on a year and then we come with the product at the end. Last year we participated 12 international events. One of them was ETH Warsaw. Like Stan is also one of our supporters, old friend with Jakub from old days like in 2018 and 19. And altogether right now we have 20 dedicated people. Apparently right now all of us are from Poland because over there we have good engineering ratio and also like pretty great talent. So maybe let's start with a very simple question, what's an oracle? So oracles, for those that know, deliver various types of data on-chain for smart contracts and dApps. To visualize the flow, on one hand, you have various sources of data, you have an oracle, and then you have various ecosystems that the data is delivered to so that dApps and smart contracts can utilize that data for their protocols, right? And right now, the Oracle approach is fairly simple, I would say. So you just take the data, you put it on chain with a heartbeat, so an interval, or a specific deviation, and you update it regardless if anyone needs that or not. So it's just like outside of usage, it's just updated depending on the specific variables that you put over there. So we compared it right now to modems in the 80s that apparently were quicker than nowadays oracles as it is on the market. So we, and mainly like Jacob in the very beginning, had the idea, okay, we need to disrupt that space and create something that you can truly build the new financial system on top of, right? Because on that, you cannot. Like a quick example, ask any of your TradFi guy to come over to DeFi and tell them that the price feed is updated every 15 minutes. He's going to look at you and say like, huh? Really? Right. So what are the problems? Why we have such a market? So because pushing data on chain is expensive, it's non-scalable. So if you introduce new data feeds or you update it more frequently, your costs grow exponentially. So you can offer unlimited feeds, and the data is updated in very large intervals. And in 2020, 21, 22, 23, and as we go farther down the road, we see that the multi-chain or multi-layer 2 world is going to be the one that we'll be existing in. So it's not enough that you push data only to mainnet Ethereum. You have to push the same data to many ecosystems, which creates huge cost, right? Like the more ecosystems you have, the higher cost it gives you in the end. So DeFi potential right now is limited by oracles, especially on, for example, recently launched ZK Sync Era, that we are already present, but many other incumbents cannot be that quick to launch at. Arbitrum, Polygon, or also like speed-optimized layer 1s like Avalanche or Phantom. So now I will give you some food for thoughts. So you just not listen to me, but you can also put your brain into work. Ask yourself, who requires data? Layer 1s and layer 2s or dApps? The second question, can we deliver data to dApps omitting on-chain storage? So these are two different questions, but very important ones. And the third, last, if not, can on-chain delivery happen on demand instead of a heartbeat, right? Because we already see the heartbeat or deviation. Can there be some other rules upon which we update the data? So answer to the first questions, dApps require data for their smart contracts logic. Like if you push data to Ethereum, Ethereum is not going to send you like a thank you for data. I mean, it's useless for Ethereum as a chain. It's rather the dApps that are built on top that needs that. We can deliver data directly to dApps, omitting on-chain storage. Because, as I said, like on-chain storage doesn't require it, the dApps require it, so we can, instead of pushing on-chain, push it to dApps, and then their job would be to deliver it on-chain. Last but not least, if the architecture of the dApp doesn't allow us to put it to the dApp directly, because sometimes that's the case with the architecture, we can at least optimize the flow. If a dApp requires on-chain storage, we can still optimize the conditions upon which are the data updated on-chain. So for example, we can adjust the heartbeat to them or make it more like on-demand level as a dApp for a specific dApp. And now I'll pass it to Jacob on the more technical part. So the easy part is over.
Okay, so networks like Ethereum and all of the equivalents following the EVM specification were never designed to store a large amount of data. Actually, like putting the information on-chain is penalized and disincentivized, as you need to do a lot of hops in the Merkle trees, fetching the data, a lot of input-output operation, etc. So it's very costly. And therefore, as we express the price in gas, let's imagine that you want to put like 1 gigabits of data on-chain. On Ethereum, we are going to pay about $80 million. Why? There are alternatives. So when we started working on that solution, we looked for a chain that is decentralized enough, but was designed and built with the purpose of a storage layer. And we discovered Arweave, started working on that. So for the persistent storage of data feeds, we utilize Arweave and then get lots of saving compared to putting data directly on chains that are going to consume the information. And still, when the data is being put on the Arweave network, somehow we need to access that in our contracts that are run on the Ethereum network. But we still can avoid getting true storage and can basically use only a call data structure. So the data is ephemeral and only available within a context of a single transaction. And the call data, as you may look, compared to other storage solution, is the cheapest alternative. So if we keep the data only in the call data during a transaction, then compared to getting that from storage and first putting that into storage, we can have a huge savings. So the traditional Oracle models work like there are multiple data providers that are pushing data to various chains. And you may notice some redundancy. So the arrows on the left side of this picture usually are the expensive operation, because you need to take data, put it into storage. And all of the data providers will need to do the same job again and again, pushing the data to different chains. And if you imagine like having 20 EVM-compatible chains, then you need to pay the gas price of each of them. And then the dApps can go to that chain, fetch the information, and make the user happy for having the available data on chain. What we changed in the design was the introduction of an intermediary layer. We call it like a data delivery network, which is combined of the streamer, which is a decentralized PubSub network. It's great for keeping the data for a short period of time and broadcasting it through the network. We also, as I mentioned, utilize Arweave for the persistent storage. Actually, it's a very nice combination because one gives you a very fast distribution, another one gives you like a full persistence, and we also use our own gateways just to make the interaction easier for dApps. So in our case, all of the data providers are pushing the data to the data delivery network. It stays there, and only when a user wants to interact with an application or a protocol, then the data is injected automatically to a user transaction and consumed on chain. So this, and the same information, the physically the same data packages could be consumed on various chains because the data is only injected to a transaction when it's needed. The data delivery network remains the same for across all of the various chains. So there are a lot of savings as the storage in the data delivery network is very cheap. And obviously, there are a lot of nice benefits as the same application can basically use the same architecture if it's deploying on multiple networks.
Yeah, so as you can see on the first target layer 1s and layer 2s, these are like all EVMs, layer 1s and layer 2s, but we also started going beyond. So the first non-EVM connector that we created is for StarkNet. Right now we are finishing one for Fuel. We also have one for Stacks, and there are other on the way under the development. So on EVM, it works out of the box. If we go outside of EVM, it's still possible, but it requires a bit of research and custom development from us.
Yeah, but generally the system is very modular. So even if we are targeting a non-EVM chain, it doesn't mean that we need to deploy the infrastructure from scratch. We just need to prepare a new adapter, something we call a connector, on a dedicated network, and it can consume the same sets of data. But there isn't a solution that fits it all, and definitely when we are talking about DeFi protocols, there are a lot of innovation happening there. So I've been describing to you the on-demand model when a user interacts with a chain and the data is automatically injected. But also recently we started working on something we call Model X, which was inspired by the cooperation with GMX, especially the work on the V2. And in that model, we try to totally prevent any front-running possibilities. So in that situation, whenever a user interacts with an application, we record the intention to make a transaction, like open a position or increase a position in perpetual. And then that intention is being settled in the very next block with the price delivered by Oracle, but the price is not known both to the protocol and to the users, so it cannot be front-run. Because with a standard Oracle model, there's always a small delay between the data that's already on-chain and the moment when a user is interacting with the protocol. So the user can have access to the current state of the market, can discover the price before it's been put on-chain, then there's obviously an opportunity for arbitrage and exploit the protocol. But when the user needs to commit to a transaction before knowing the price, and the price is settled after that, then we eliminate all of the possibilities of arbitrage. And also when we started working on that solution and cooperating with various protocols, some of them are more traditional. So they got a code base that was well audited. They are used to work in a certain way. And they do not want to experiment with oracles and use a standard approach based on the interfaces implemented by incumbents like Chainlink. But still, you can benefit from having this decentralized distribution network using a classical approach by specifying what will be the rules of pushing data on-chain automatically. So we are not limited by the scenario when a syndicate decides how the data is being pushed on-chain. You can define your own rules, providing a relayer, and still fetch the data from the same source whenever it's required, by being 100% compatible with the old interfaces. So basically, how it looks from a point of the user, it's exactly the same as interacting with the standard dApp, apart from the fact that behind the scenes, we are injecting an extra payload to a user transaction. It's all automated through our wrapper on Ethers.js. And this extra information are the packages of sane data. So despite we aggregate and keep the data off-chain from the point of view of a target chain when the protocol is deployed, still the verification happens on-chain. So we derive the security from the target network. When we are deploying that on Ethereum, all of the verification of signatures and timestamp happens on Ethereum. We also are integrated with multiple data sources. So for I think there are more than 50 sources, and for the most popular tokens, like for example Ethereum, we got like 40 sources. And we parse this data about all of the individual sources, and they are publicly available on Arweave. So if you are interested into the history of the price, for example, of Ethereum in the past, and would like to compare the data coming from various sources, then you can have access to that as well.
By the way, the price of Ethereum wasn't from today, like easy. I mean, I saw that some of you that might be shorting had a heart attack, but yeah.
No, it's from the next week. So we provide custom data feeds. It's not only the prices of tokens, but also some commodities, currencies, also derivatives like stake tokens, LSDs. We got to provide prices for LP tokens. And also for some hackathons, people are creating a really interesting use cases. We've been on one hackathon in Ukraine, so they decided to put all of the information about the war on chain. And the protocol is very customizable and open for anyone to put any data feeds they want. I'll let you summarize.
Yeah, so as you could see, like the bottom line is, in 2023, we need more customization depending on the dApp. We cannot think about in the same terms as we did in 2020 DeFi summer, that there is like one approach to oracles, and let's push it to any dApp that will use it in the same way. dApps want to be capable of defining what's the heartbeat or are the rules, what data they require, like what are the data feeds. And in our model, we also allow the dApps to see who from they consume the data, which means you don't just receive at the very end the final aggregation, you can track like who this specific price feed came from. So we take the data off-chain from enterprise-grade data providers, Kaiko, Flow Traders, CoinGecko, CoinMarketCap, and many more. And for example, if you as a user don't like a specific data provider, you can disregard this data provider. To give you a real-world example, imagine we are in August 2022. You already smell that something is bad with FTX, which apparently was a data provider for many oracles. And you could potentially, for example, disregard the data that they provided and omit a potential crash of theirs later, right? Or even if you are consuming, you have the information that you are consuming from FTX. And when you see the FTX crash, you know the anomaly is because you are consuming data from them, not because of the whole market is volatile and so on. So you have better like transparency across the whole usage. We also integrate data from over 50 biggest centralized exchanges, but it's not limited to that. We also take data from on-chain sources. So we can provide you a TWAP, LP tokens, specific tokens for the ecosystem that you can ask for, liquid stake tokens, you know, like right now it's very trendy topic, or NFT and other types of data. So a couple of benefits of that design to sum up. So it's scalable, so more networks, and it doesn't require from us to have like higher costs of keeping the system. We cover right now over 1,000 of assets and non-starter data, and nothing stops us from adding like new sources if you need so. We, right now, in a core model, update price feed every 10 seconds, and with the Redstone X, so this no front running model, we can go even sub-seconds. So right now on Arbitrum, we are testing delivering price feed every block, which is like 0.4 seconds as far as I remember. And it's cross-chain by design, so there is no waste of gas when you require data. So the data is delivered where you need it, when you need it. You can check out the interface with the data that is available on app.redstone.finance. And our documentation is very much updated as well. It's docs.redstone.finance if you want to dig yourself and check out what's possible there. So maybe a bit about the market trend in DeFi. So as you know, last year the whole DeFi shrinked, whereas the specific DeFi protocols such as derivatives, perps, options grew when it comes to TVL and basically the interest from users. So this Redstone X model, here is a bit of a more of a breakdown, is a perfect fit for them to leverage the frequent update and omit the front running, because when you have like a lot of trades, of course, front running seems like a lucrative option. So let's recap on an example. So first, you have a user that, for example, his request on GMX would be to open a short position. This request is registered in block number N on Arbitrum and via GMX. The price is not known yet. Anyone who works as a resolver can basically pick that transaction, pick a price from our data delivery network, connect the two, so you have price P with block N on the transaction, give it back to GMX, and GMX makes the settlement in the very next block. So between 1 and this N and N plus 1, you have 0.4 seconds. So then there is truly like no time for any front running for other users. So when it comes to protocols that trusted us, we've got a bunch on various networks. So for example, Delta Prime in February was top 3 quickest growing protocol when it comes to TVL and DeFi Llama, because we provided them feeds that no other Oracle could, like GLP token, you know, like in February it was a very hot one, and other like staked AVAX and so on. ZKX is on Starknet, so it's our long-term partner, Mula on Celo, and so on. From the notable ones that we are right now finishing integration for, it's Mento Labs, so it's the biggest DeFi protocol on Celo, Poolshark on Fuel Network, so the one that is coming fairly soon, and we are also chatting with Olympus DAO to prepare like specific dedicated solutions for them. So here's like Oracle in practice, how the Delta Prime model works. I don't know, you want to go ahead?
Oh, I can jump in. Give you some rest. So it's a very interesting protocol, kind of a decentralized prime brokerage service that allows you to multiply the effects of your money. So you get an account, let's put you, and you're putting there, let's say like 100 USDC, but actually you can trade, you can invest, or you can farm with, for example, $500. And so you can borrow much more than you can deposit. So that's the opposite of lending protocols like Ava. And on any action that the user executes in that protocol, we attach the information about the prices of the assets. So whatever the user is doing, the value of all the assets that's being held, all of the invested positions in, for example, LP tokens or stake tokens, need to exceed an initial margin. And so, and that checks are automatically applied to any user action, but obviously what's going to happen, let's say I put $100, I invested into LP tokens, and now the cumulative value of that position is something like $420. So we are getting close to our limit by a margin, which was this $100 supplied upfront. So for the security and for the solvency of the protocol, we'll need to liquidate the user position. And in that case, also the bots that are monitoring the system, and that could be run by any of the external users, need to monitor the price, read the price from contracts using our oracles, and liquidate the position. So it's both the data is injected to user's transaction, but also in the same way injected to the liquidation bot's transaction. And as I mentioned, the protocol could be used for trading, staking, or liquidity mining.
Yeah, so at the very end, we also wanted to invite all of you for the partner event of Ethereum Zurich, which is like E4, conference and a hackathon, starting 30th of August and happening until the 3rd of September. So over here you have the university vibe, right? Over there we also organize it at Warsaw University of Technology. It's a 19th century building, which is fairly cool. So I would love to see all of the faces over here also over there in Poland. Thanks a lot for listening. I hope there is a moment for questions. Yeah, we are very much open to hear your feedback and questions.
We are a bit over time, but it's just the whole day. Don't worry, not about you guys. But we have time for one, tops maximum 2 questions.
So do I understand correctly that if you're providing very frequent updates, for example, more frequent than the block time of Ethereum, which is 12 seconds, then the user of your oracle actually gets to choose which of the time points they submit?
Yes, so it's up to a protocol to specify what's the allowed delay of a price feed. So even if you are on Ethereum, you can specify, for example, that you are going to accept only the price that is like, say, like 5 seconds old. So it's been enforced and checked at the level of a smart contract. And then there is the validation of a timestamp. So it depends on the protocol. Usually, let's say the acceptance margin is larger. But if you are afraid of any kind of tricks done by user, picking the most beneficial price, you can simply shorten the window, but as a trade-off, some of the transactions may not be mined if they are outside of that window.
Thank you very much for the presentation, very interesting. I'm wondering, are we introducing new centralized attack vectors here, like when the debt then talks to the resolver, then that's like a URL he needs to resolve to get the resolver that then access the data pool? And I mean, the verification on-chain, then it's clear there we can check the signature, but what are the central attack vectors between in the whole process?
I think, yes, that's an excellent question, because if we got this intermediary layer, like how can we trust into that, and what's the security guarantees of this intermediary layer? So therefore, we decided not to only build our own solution with something we call like a gateway or cache nodes that are used in the networks, and they're like a passive element. They just need to take a signed package and push it forward, so they cannot tamper with the content, but they may, let's say, stop working. And on that front, the code is open source. Anyone can spin up as many nodes as possible, but we also decided to work with an external solution provider, in that case, the Streamer network. I think they are even based in here. They are from Switzerland. And they got a very good and interesting and well-thought-through solution for the decentralized and accessible public subscribed network. And we utilize that also as an alternative to our own nodes, just to have a higher level of security, because we do not control the network. It's only a very passive mechanism when we push through the signed packages, and we benefit from, I think, around like 50,000 streamer nodes that are broadcasting the information.
Thank you.
If you have further questions, join our Discord and follow us on Twitter, redstone_DeFi.
Perfect, exactly. I was just going to say the same thing. Everybody put your hands together for Marcin Kazmierczak and Jacob Wojciechowski. Perfect, thank you. All right, from oracles to oracles. Our next speaker is working also on oracles, and his goal is to make sure that oracles stay the super information, high-speed highways instead of becoming bottleneck gatekeepers. Everybody, put your hands together for Nick Kunkel from Chronicle.
Awesome, thank you. Just make sure this works. Great, perfect. Okay, so today I'm going to be talking about decentralized infrastructure in a multi-chain world. I know this is an Ethereum conference, but I'm kind of here to convince you that the future is multi-chain. So let's kind of take a step back in time. 1994, Nick Szabo publishes a paper where he defines what this idea of a smart contract is. And what he basically says is that smart contracts are computerized transaction protocols that execute the terms of a contract, right? Just completely visionary. In that same paper, he also creates this idea of a token, which it's a little more abstract in the way that he describes it, but I think you'll find it sounds very familiar, right? And he says that these new securities are formed by combining securities and derivatives in a wide variety of ways. Very complex term structures for payments, can now be built into standardized contracts and traded with low transaction costs, right? So this was 1994. I mean, before some of you were even born by the looks of the audience here. So what can we say then? Well, in 2013 then, when Nick Szabo says something, we should probably listen, right? And so here in 2013, right, you have Nick Szabo basically saying that, right, there's going to be this polycentric blockchain ecosystem, right, that the future is going to be multi-chain, right, that we're going to have a diverse array of functionality, security characteristics, right, that would be difficult to achieve all on one, single almighty monochain. Right? And that a polycentric system, right, is more resilient, right, to pressure, right, and then it's also more innovative, right, because competitive pressures, right, will cause these chains to evolve. Okay, so Nick Szabo was right. In the decade that followed, right, we have this hugely diverse array of blockchains. Don't kill me if you don't see, one of your favorite chains. They're not in any particular order. I just needed to get the logos on the page and kind of have them line up, right? So we're not maxis of anything here, right? But now what, right? Are we living in this kind of like multi-chain utopia? Like, have we solved all of the problems? Well, not quite, right? We kind of have new challenges that we need to address, right? So with a show of hands here, who has used more than one blockchain? Amazing. So let me pick on someone. You, sir. Which? Yeah. You looking back. Which chains have you used? Okay. So which one was first? The very first one for me was Bitcoin. Bitcoin. Okay. So when you switched from Bitcoin to, I'm guessing maybe Ethereum was the second one. Were there any challenges that you encountered? Anything new that you needed to learn? Was it difficult to use it the first time? Mm-hmm. Exactly. Do we have any developers in the room? Okay, great. So any developers that have worked on multiple blockchains? Okay, you sir, which chain did you start with? Ethereum. Ethereum? Yeah, Solidity. And then what came after? Polkadot, Substrate. Okay. You dropped it. Okay, no, that's interesting. You dropped it very fast. Why? Why? What was different about what you could do on Ethereum, and then like how was the developer experience different?
Well, the entry level was way more bigger. So because you have to learn Rust, which is very different from Solidity, and Substrate as a framework. I think that was 2019, so it was like very early ages of Polkadot and Substrate, and it was not ready yet for building production-ready stuff. I just realized that the entry level is way higher, and I would get more money by just writing Solidity concepts.
Yep. 100%. Amazing. Right, so I hope you're starting to notice some like common themes here, right? That there are certain characteristics of different chains, right, that present challenges both to users and to developers, right? And so, there's certain chains, right, have taken certain strategic approaches, right? We sometimes classify chains as being like EVM or non-EVM, right? And as a developer, right, if you have worked on an EVM chain, right, it's incredibly appealing to be able to jump to a new chain, right, and not have to redevelop your smart contracts, right, to be able to recycle a lot of the developer tooling, right? So maybe on a newer chain that's not EVM, you don't have some of the advanced like stack traces and stuff, right? It's great to be able to use, right, simulation tools like Tenderly or auditing tools, right? So there's incredible synergies when we have this standardization of infrastructure, right, between these chains. So, and in the few instances where we have this synergy, this kind of standardization of infrastructure, it's proven really useful. Right? Like as a user, right, if a chain doesn't use MetaMask, I can tell you like most people just will not use that chain, right? It's just too different from what they know, right? The ability to recycle your keys and not need to have different keys for different chains, right? This is all very, very useful, and we need to do more of this kind of stuff. So, in light of that, these are kind of like the three takeaways of what I think we need to aim for in decentralized infrastructure. We need to be compatible, we need to be interoperable, and we need to be verifiable. Right? So let's kind of walk through each of these, right? So we want infrastructure that's going to be compatible across all chains. Right? We don't want to have to reinvent the wheel. It's a waste of time and resources, right? And it throttles, right, the most important thing, which is, right, that we just want to get on with our lives and like make the dApps and innovate, right? 2, interoperability, right? Blockchains need to be able to talk to each other. They need to be able to talk to the outside world, right? That's the only way that you're going to take this like fragmented islands of like pockets of functionality and utility and liquidity, right, and merge them together, right, as this interoperable kind of property, right? That's really useful. And third, right, we need the infrastructure to kind of have provable integrity, right? We need the transparency, right, for everyone to be able to verify this integrity, right? Not just some fancy computer or like developer, right? You as a user should be able to have like, to be able to see and understand these integrity guarantees. So, breaking down kind of compatibility a little bit, right? There's reasons why, we talked about the EVM, right? There's reasons why many chains adopt the EVM, right? It's not that the EVM is the greatest virtual machine in the world. It's really not. Actually, like if I'm being honest, it's quite poor. But it's really useful, right, for bootstrapping your chain, right? You get all the developer tooling, you get users don't need to generate new keys, right? You get things like MetaMask, right? So the interfaces for users to use applications, right? You get all of this stuff for free, right? And you can quickly bootstrap your ecosystem, right? Developers can just port their existing contracts onto your chain, right? There's a lower barrier to entry, right? You talked about this, right? The lower barrier to entry to being a developer and moving to a new EVM chain. It's easier for the developers of that chain to find talent, right? Because there's already a skilled workforce, right? So these are very natural, like organic forces that push us in this direction, and they're good, right? They're not bad. Going into interoperability a little bit more, right? What makes DeFi so powerful, right, is its composability, right? Has anyone here used 1inch before? Yeah. Do you remember the first time you used 1inch, like that wow factor of like, I don't have to go check for like the best price anywhere, right? I just use this application and it just magic happens, right? That like feeling, right? That magic happens, right? That's composability, right? It's the ability, right, to stack all of these primitives on top of each other. And, you know, right, even something like Yearn, right? Instead of trying to cycle your funds between Compound and Aave and any of these other yield-generating, right, protocols, right? You know, Yearn would just rotate you to wherever the best rate was, right? These are really powerful network effects that are only possible because of composability. And so now when we talk about multiple chains, we need composability across these chains. And that's really, and that's kind of where interoperability comes into play, right? Interoperability, the ability for chains to communicate with each other, is what's going to enable multi-chain composability. Oh, sorry. I guess I forgot to switch the slide here. But anyways, and the last one, right, is verifiable, right? We need this infrastructure to be credibly neutral, right? And have the transparency, right, for people to be able to verify the integrity of this system, right? There's too many infrastructure services that right now both users and applications rely on that are, you know, complete black boxes, or they're totally centralized, right? And we don't have strong integrity guarantees there, right? You know, others claim to behave in an unbiased manner, but we have no way of verifying that, right? You know, just to get into a few like recent examples, right? Relatively recently, right? Tornado Cash was sanctioned, and you may or may not have very strong feelings about, you know, your ability to use Tornado Cash, but it should be your choice. And the way that we've designed our applications to be dependent on these more centralized, right, infrastructures has disenfranchised us of that choice, right? So to give you an example, right, Flashbots. When Tornado Cash was added to the sanctions list, Flashbots would only generate OFAC-compliant bots, right? And this is really dangerous, right? Because you know, deciding, you know, what goes in or does not go into a block and like censoring on the block level, right? This is really, really, really low level, right? Censorship, right? I'm not trying to argue, right, that we shouldn't, as an industry, right, we shouldn't comply with our compliance obligations, right, or that we should. What I'm just saying is that it shouldn't be that far down the stack, right? It should be something that happens on the application layer, right, where each application, according to its own circumstances, right, or even the users, according to their own circumstances, right, choose, and not have it be, right, way down the stack. And we risk, the more we use, right, some of these centralized services, for example, Infura also, right, banned any transactions involving Tornado Cash. They even do it today, right? So if you are using, you know, MetaMask, right, you're implicitly using Infura, you will not be able to do a Tornado Cash transaction today, right? Because it's being censored on the infrastructure layer, right? So it's very important, right, that we have infrastructure, right, that is credibly neutral and that we can verify, right, its neutrality. Okay. So with that, I want to get to you that all of these challenges, right, of having infrastructure that is, compatible, interoperable, and verifiable is why I created Chronicle. So Chronicle is building decentralized infrastructure, right, that is compatible and interoperable among all blockchains, right, and we want to do it in this transparent and verifiable manner. And so you might be thinking that, you've never heard of Chronicle, we're probably some new protocol. Well, actually, we're one of the oldest and most battle-tested protocols in pretty much like blockchain history. So we spun out of MakerDAO, and I was part of the team that launched the first, or I would say one of the first. I think Oraclize beat us to the punch, but one of the first Oracle protocols in all of Ethereum, and really just one of the first protocols, period. Right, so we launched this in conjunction with the launch of ProtoSci, which was the precursor to single collateral DAI. And since then, right, we've been securing all of the assets and loans that were extended from Maker, which currently today is $10 billion. And in previous years, right, during the bull run, this number was even substantially higher. So that actually puts us, in terms of total value secured, as the second largest Oracle provider, right after Chainlink. And this is sourced from DeFi Llama. You can check it yourself. Okay, so I want to talk a little bit about the architecture that we've made, and I hope to be able to describe to you, right, why we're compatible, why we're interoperable, right, and why we're verifiable. Why you should be able to, with your application, right, or as a user using applications that use Chronicle, why you should be able to trust those applications and those services. So we start with this concept of feeds. Right, and feeds, you can kind of think of it as like as validators, right, or signers of a multisig, right. The point is that you want to have this distributed consensus being made, and you want these feed clients to be run, right, in a distributed fashion, right. You don't want any point of centralization, right, or coordination centralization either. And what these feeds do, right, is that they're constantly just querying data, right, from, let's say, if you have a price oracle, right, querying data from exchanges, querying data from on-chain, right, if it's an oracle for powering a bridge, right, you may need, to know what's happening on blockchain A and report that, right, to blockchain B. But again, right, the way that you query data, right, you need to have redundancy and resiliency within this process as well. So we don't actually just have one tool for querying data. We actually have multiple implementations. So in this chart, right, it's described as Gopher and Setzer. So Gopher and Setzer are completely independent implementations, right, that implement the same kind of data standard. And the idea is, right, that if one tool were to fail, right, we still have fallback on a different tool, right? And that's very important. Building up, right, this resiliency, so one bug, one failure, right, just doesn't take down the entire network. So what do these feeds do? Well, after they get the data, right, they do some data processing according to a data model, and then they sign it. And once they sign it, they broadcast this kind of this message, right, to what we call a transport layer. And transport layers are peer-to-peer networks, right? So there's no centralized server or anything involved, right? There's no bootstrapping nodes or something, right, where if someone's not running one of these, right, that no one can connect to the network. They're completely open networks. So you could try to connect to any of these networks right now. So we have libp2p, we have secure scuttlebutt, and actually we just last week implemented a third one, You may have heard of it. It's called Tor. So between these three different networks, all of the messages, all of these signed messages are broadcast to all three of these networks, right? And in the future, right, we could even add additional networks, right? And the idea is even if there is a 0 day in one of these networks, right? Even if there's a DOS kind of attack, right? Even if there's a way to compromise one or more of these networks, that the architecture is kind of, that the data is kind of like water, right? It will just flow through the path of least resistance, right? And the data will get through in some way, right? So this idea of resiliency behind the infrastructure is incredibly important to us. And then on the other end of this network, you have what's called relays. And relays are essentially just homologating all of these batches of messages from these independent feeds and compressing them into a single transaction, which then gets pushed on-chain to a smart contract. Relays are permissionless. Anyone can run a relay. You can run a relay right now. Even without running a relay, a user could just go to our website, push the button, say, update, I want to update the price, and the price will be updated. You'll sign the transaction and pay the gas. But it's important, right, that this, even without incentives, that this is like an open, kind of like permissionless role. And so one of the things that I want you to notice about this architecture is most of it is off-chain. It's not on-chain, right? It's not specific to one particular blockchain. And this is what gives us that compatibility feature, right? In that only the last mile, right, has anything to do with the blockchain, right? And so it's really, really simple to deploy this infrastructure across multiple blockchains, because the only thing you need to change is, well, which RPC is the relay you're pointing at. On the topic of interoperability, right? Is this architecture interoperable? Well, yes, because the data source can be anything. It can be, yes, it can be an exchange like Binance or Coinbase, but the data source can also be another blockchain, right? And so if you're gathering data from blockchain A and relaying that data to blockchain B, right? Attesting to blockchain B that, hey, something happened on blockchain A, right? That is how you get interoperability, right? That is how something can happen on blockchain B based off what happened on blockchain A, right? And the last is verifiability. Oh, sorry. We'll talk for a second first about the feeds. You might be wondering, well, who the hell is running these feeds? Why should I be trusting these people? So the feeds right now are run by the projects that you see behind you. Most of them have been running their feeds since, I want to say over 24 months now. Most of them right around the time of the launch of multi-collateral DAI, which was in December of 2019. So we have some great partners. We love working with them, and we're constantly looking to add more. Right? And essentially, right, what we look for is we want someone that has, right, high credibility and a high reputation in our ecosystem. Because essentially these feeds, right, are the entities that are reaching consensus, right? And they're effectively staking their reputation, right? So if, for example, let's say Maker, right, were to try to participate in some kind of Oracle attack, I mean, it would be, suicide, right, for Maker's reputation. And Maker might lose a lot of their users because why would anyone want to ever, use or interact or benefit a protocol, right, that is a bad actor, right? And so essentially the trust model here is that, like, maybe you don't trust like individually like one of these protocols on here, but the consensus of all of the protocols in our industry, right, the community consensus, that's harder to argue with, especially when you use some of these applications every day and already implicitly trust them. Okay, so this is kind of this idea of verifiability, in that we don't just want cryptographic liability, but we also want verifiability, right, to like the layman user, right? So very frequently you'll see like an oracle and just be like, here's the price, right? And you're just like, how did that price come about? Or maybe I understand theoretically how it came about, but like I cannot track the steps from like, here is where we got the data and here is how we transformed it, and that's how we achieved this number on chain. So kind of below the chart, right, we basically have a list of all of the feeds that were used during the consensus process, right, for reaching, right, the canonical price of the oracle. And then if you were to click on any one of these feeds, right, you'd be able to see the exact data sources of how each individual feed arrived at that price, right? So here you can see, right, that we pulled the ETH Tether pair from Binance US, right? We pulled the ETH USD pair from Bitstamp, right? We used an on-chain source. I believe that one is Uniswap v3, right? We used Coinbase. Right, and the feed took all of that data, right, and decided that after crunching it through the model, the closest price was this one, right? That's what it ended up reporting. All of the feeds individually do this, right? And now you can use different types of consensus models, right? So in this case, we're using a median, right? But there's no reason why you can't use a TWAP, a VWAP, right? You can transform the data in any way you want. It's just based off the definition of the data model that you plug in. And these data models are also on-chain. So there's an on-chain register, right, where these data models are defined. So when we say, well, how do you decide? How does a feed decide what the price of ETHUSD is? Well, you can go check in the on-chain register. Here is the data model, and the feeds are querying this on-chain contract to get the data model, right? So it's not like some pre-programmed thing, right, where we can just slip in some hard code, right, where the developers overwrite the rules of what ETHUSD is, right? We cannot do that. So I mentioned earlier, right, that this architecture is compatible with any chain. EVM is super easy, right? Because it's really just, even the smart contract is just deploying the same contract on every chain. But even non-EVM, right, is not difficult, right? You have things like Solana, you have things like Cosmos, and the only thing that you change, right, is you change the implementation of the smart contract, but everything else stays exactly the same. So we're publicly live on Arbitrum, Optimism, and Ethereum. But we have 6 other blockchains that we're kind of doing in secret right now, and that will be announced in the next couple of months. We're going to have a particular focus on the layer 2s, but some of the more popular layer 1s will be in there as well. So, you know, if you were interested in what I talked about here today, and you want to find out more, or you want to stay updated, you can follow us on Twitter or join our Discord by there's an easy link by going to our website. If you would like to use Chronicle in your applications, you know, you can reach out to me on Twitter or reach out to me on our Discord, and we'll be happy to get something set up with you. And even if you're interested in working for Chronicle or working on Chronicle, we're always hiring. We don't care where you are in the world, right? You know, your salary is not going to be regionalized or any of that crap, right? We just want the best people, and we have like a remote distributed team that's basically across, I think, 14 different countries right now. So come talk to me, or even if you see me here, come talk to me, come find me. Let's talk. Thank you.
All right. Thank you very much, Nick. Do we have any questions? Oh. First question here.
Hey. Hello. So I have a question about the transport layer.
Sure.
So you had two independent kind of modules in the transport layer, which is libp2p and secure scuttleboard, right?
Yep.
Why? And you also mentioned that you have the third one in a way. Why to have three independent like modules? Or are they independent? Firstly.
Yep, they're completely independent, right? And because one could get hacked, right?
Why not three of them can be hacked then? Like if one can be hacked, why not
could,
three?
but probabilistically, the more you add, the more the less likelihood, right, that all of them can be hacked at the same time, right? These are all open source protocols, so you would imagine, right, that over time, right, if they are compromised, right, that they will be fixed and they will become hardened protocols, right, and they will build up some Lindy. And I mean, you could even add a centralized server there if you wanted to. We actually had like an internal hackathon where someone actually created this cool concept of like, what if we just threw the data up on Twitter, right? And it's like, oh, well, Twitter's like, you know, terms of service doesn't let us, you know, just like put up JSON, you know, into a tweet, right? You would get banned. And so what we ended up doing is we just said it's art, and we just encoded bitmaps with the data. And so you would just have feeds tweeting like all of these pretty like bitmaps, and we just said that they're like, you know, AI generated art or something, right? And so it's okay, but right now they're all right peer-to-peer distributed decentralized protocols, but you could still gain extra resiliency by using centralized services as well, as long as you're not reliant exclusively on centralized services.
And who currently run the nodes of these peer-to-peer services? Who operates the nodes of these products?
So the networks, right, are composed of the different participants on the network.
Yeah, true.
Right. So again, right, there's no bootstrap node that we run and then everyone connects to us. No, they're peer-to-peer. So everyone is just connecting with each other. So it's the feeds, right, that are part of the network. It's the relays that are part of the network. It's people that just want to monitor the activity of or performance, right, that are part of the network. They're open networks. Anyone can be part of them and join them.
Are there any incentives for someone who wants to run the node in the transport layer? Are there incentives for it? Or
currently, no. We may add those incentives in the future, right, to make the network more resilient and robust, though. That's definitely something to think about.
Yeah. Thank you.
Do we have another question from the audience?
Cool. Thank you.
No questions? Great. Thank you very much, Nick. All right. We're coming to the final speaker of today on this stage. And he's going to explain to us the transition. How does a protocol transition from being a blockchain to a blockchain operating system? And what does this new paradigm mean? Yesin Shirk is our next speaker, and he will explain to us how his team members at NEAR and Yesin are tackling this paradigm shift. Put your hands together for Yesin Shirk.
Thank you very much, everyone. Thank you for staying. It's the last session today that you've been biting through today, and have been staying around for my speech. And I want to treat you, entertain you, and invite you for a drink afterwards for that. My speech will be about sausages. Actually, it's a specific type of sausage. It's a Swiss sausage called Cervelo. And I will be throwing some of these at you. Fetch. Another one. Oh, that's all the way up. There you go. So Cervelo, there's a concept of Cervelo Promi, which is sort of a sausage celebrity, which in Switzerland means like a local celebrity. People know him. People make or her make a bit of fun about him or her. And internationally, no clue who that is. So that's like a sausage celebrity. And I want to be your sausage celebrity today. Why that? I grew up in Zurich. I'm a resident of Zurich. And I'm a citizen, a formal citizen of Zurich. Well, we as people from Zurich are popular for our big egos, but that's not the clue. The clue is, out of the several 100,000 people that qualify with the same, I'm probably the one who was the first with the Ethereum team. I joined the team in 2015 and stayed for a bit more than a year. And that makes me a Serverless Promi today. And therefore, I want to tell you a bit about that journey. I actually started as a Bitcoiner myself. And I'm surprising all the Bitcoin maxis with whom I'm often in debates with that. I was a Bitcoiner for about 1 week. After I discovered Bitcoin, I quickly discovered Ethereum, which is sort of programmable Bitcoin, and that blew my mind. I knew that will change everything. So I was so excited about it and realized that Ethereum was actually in Switzerland, actually in Bar, and I was working close by. And so I figured I should just go there, ring the doorbell, and ask if I can help somehow. So I pretty much did that when Marty McFly set his target for his time machine to 2015. About at that time, I landed with Ethereum, and I thought, like, I gotta impress these guys somehow. And these electric scooters were not a thing, and I was importing quite a few to test them from China, and was thinking about doing a business with them. So I was already a bit into tech, all by being a banker, financial background guy. And so I arrived at Ethereum. That was the mailbox, by the way, with all the people that lived there. So when someone new moved in, they listed them Ming Chen at the very bottom, or crossed people out as they moved out. They were all packed into one villa in Bar. So I'm arriving with my scooter, and Ming Chen is actually on site, and she is totally excited about the scooter and also about my personality. So she proposed, you should meet Vitalik. She handed me that business card. Yeah, I was very excited to contribute, and then the first question to me came up, will I be a Serverless Promi if I'm contributing to Ethereum? Well, I showed up at Ethereum and a few days later and met Vitalik. Vitalik was debugging some code and interviewing me at the same time. And Ming Chen also asked me a few questions about myself. And at some point, Vitalik looked up and said, oh, I found a bug in the C++ language. And I was like, in the programming language itself? Yes. And I was like, oh, if you're that smart, why don't you develop your own programming language? And then both looked at me with big eyes and said, well, he did. Solid. So I got proposed to come onto the Foundation Council, and they sent me all sorts of docs to read into. And I chickened out thinking about that Serverless Promi idea, because at that time the Ethereum Foundation was pretty much broke, had all sorts of operational and tax challenges, and so I chickened out, and I confessed to them I just can't do it. And they said, all right, if you don't want to take that risk, we have this advisory board too, so you can contribute, help us to clean up, but you're not in the risk. And so that's what I did. Next to Stefano, Bertolo, and Bernd Lapp, we became very good friends and helped out a lot. Yeah, so if there's a single one thing to name as my contribution, then it was probably that I helped, that I had that idea with Ethereum, that because every week the foundation sold the ether they needed for the fiat they needed to pay salaries. I was like, oh, maybe you should stop that. That puts a lot of pressure on the market. Maybe do OTC sales. And so Vitalik said, like, well, I don't have time to do that. And so I took that on and sold a bunch of ether to some famous twins. Definitely not Serverless Promis. And yeah, that might have helped, and financed the team for a while. Me and Bernd became local ambassadors of Ethereum, while there was still a doorbell that read Vitalik and Ming. nobody was usually around in Switzerland. So we became ambassadors in Switzerland and were invited many times to banks, insurance companies to explain what Ethereum was about, what blockchain was about, because we were the only people on site. And yeah, that was exciting and sometimes very challenging. Once I remember we showed up at like a pitch round. There were a lot of bankers and they told us, you got 5 minutes to tell us what this is about. And so we explained them and they said like, wait a moment, no equity, no dividends, just tokens? What the heck is this? Get the hell out. And so that's how it ended that time. But usually we were well welcomed. So we organized also all sorts of happenings in Switzerland, which were very fruitful. So you will bump into many people that are on these pictures, which are also here today at this event. DEF CON was a great experience, DEF CON in Shanghai, DEF CON 2. And there was this, I organized a t-shirt sale. Everyone wanted to have one of these. So we ran out quickly. And there was this one, or I took the money and put it to the hotel safe and went for drinks. And there was this time where the whole Ethereum team freaked out because they were like, hey, this Swiss guy, he left with all the money of the t-shirts. We gotta find him. Well, it was all there and safe for the foundation. Then later on, I became the CFO of Status. It was a funny episode, as you can see. So through Servola Promi. Eventually, I found my way to Near. So what excited me is that with Ethereum, things were sort of stuck because transaction fees were so high, and there was a very new, promising blockchain that had fast transactions, quick finality. It was very scalable. The idea to bring up sharding, so it sort of delivered on all the promises of Ethereum 2.0, and I became the CFO of the Near Foundation. Here I'm summarizing what I just said. It actually also runs the Ethereum as a virtual machine, and there is a rainbow bridge to Ethereum. And it's a climate-neutral blockchain. Now, I'd like to talk to you about why Near is the boss. Between the blockchain and the human being, there's actually one interface, which is the token. Fungible tokens, non-fungible tokens, that's how we nowadays interact with the blockchain. And it's quite simplified, and there can be quite more to it. Unfortunately, that leads to the fact that interacting in a Web3 environment is very tedious for us humans, and adoption can be a challenge. Now, what is the BOSS? It's a blockchain operating system where here are the components on how this is going to work. Is as follows. So you have underlying blockchains that can be Near, Ethereum, and other blockchains that can plug in. And you will have a data layer and a discovery layer. And on top, you can have decentralized front ends. And I brought, Pascal has been distributing link drops so you can create a wallet and experience on first hand how that's going to feel. You can see it's actually a multi-chain thing. The user experience will be similar to a Web3 user experience to live through a Web3 environment as a user. So maybe I should, let's see. So maybe I'm guiding you quickly through the link drop. So if you scan the QR code which you just received, you can claim with a new account, put a name, continue, save your secure passphrase, and then you got a wallet within your browser. And then you can scan this code. And for everyone who's not in the room and who would like to try it, you ping me on Twitter. So my handle is, let's see, here at the bottom, Yesin Šiek. And whoever follows me today will get a link drop so you can try it out as well. So I'm giving you this QR code again to scan. And once you log in, you can also head to alpha.near.org. That's what it does. You can create your user profile, and you can see how everything which you see is pulled in directly from the blockchain. As a user, you can interact through this platform, and you get an experience like in a Web2 as you're used to in a Web2 environment, and you don't even realize that your data as well as your assets are secured by blockchain. All right. Okay, this is it. Any questions?
All right, we have a question over there. First things first, thank you very much, Yesin. That's where you applaud.
Thank you.
Thank you very much. Question about your career journey. I just checked that you also learned that you also worked for Web3 Foundation for a while. Why did you switch then to Near? Because since you have worked with Gavin Wood that actually built Web3 Foundation, what was your personal decision in this change?
Yeah, so indeed, I was also with the Web3 Foundation, and through the evolution, being with stock, sort of, when I saw that the adoption was stuck with Ethereum, I was looking around and was very excited about the Web3 Foundation because it's also a third generation blockchain protocol, which Ethereum 2.0 also sort of is. And back then, that was the latest and greatest. And well, Near just started way later and was later to the game. And yeah, so I made the transition to Near eventually because I think Near is the latest and greatest. And I'm still sticking around after 3.5 years because I'm very, very excited also about that BOSS bringing a new interface between the human being and the blockchain. And development is still ongoing, it's early days, and I'm very excited to see how that's coming along and how that makes it easy to interact with the blockchain and enjoy really all the promises that are out there for the blockchain, which is like owning your data, owning your assets, but at the same time the convenience of user-friendliness, because fiddling with transaction fees is just not for our granny.
Thank you.
All right, any more questions in the audience? Here's one question. Oh, you're getting a microphone actually.
Hi, today we're testing alpha. What are the plans for when beta, when production?
Yeah, I think there's a consensus coming up in Austin, so I think that will show some progress, I guess.
All right. Thank you very much, Yesin, for your interesting talk, and first and foremost, for teaching everybody what the Serverless is. Thank you very much. Put your hands together for Yesin. I see there's some swag here, and Yesin promised you guys drinks, so I don't want to stand too long in between you and Friday night. It's been a long day for everybody. Thank you very much for sticking with us. This was the last talk for today. It was a great first day. Thank you, everybody, again. Tomorrow we will start at 9 a.m. with the first talks. We'll have here Crypto Native Economy Report 2022 by Joseph J. And we'll have in the other room cross-chain tooling presentation by Honza. and a million of other presentations tomorrow that are very interesting, captivating, and that will give you insights about the Web3 space from different angles. Thank you very much, everybody, again. We'll see you tomorrow.
777, hej, raz, dva, tři, raz.